Hello, very good evening to all of you, all my dear students. It's yours Unacademy NEET English channel, and today definitely the basic, or you can say the backbone of organic chemistry, GOC, Journal Organic Chemistry. And kids, because this is being marathon, and we have to cover number of things. So I have done homework for you, all my dear students. Lot of homework I have done for you, all the students. Definitely, because we are going to deal with Journal Organic Chemistry, which holds a whole lot of weightage for your examination. So GOC, in GOC, what I am going to tell you today, kids. First of all, just remember one thing: RHIS, RHIS, resonance, hyperconjugation, inductive effect, and percentage of S character. As the code says, RHIS, kids, resonance, R for resonance, very important. You can say the most important thing is resonance, then hyperconjugation, then inductive effect, then percentage of S character, that is being electronegativity. But as we know that resonance is the most important thing, and just to understand resonance we should know the basic thing. We will study first the electronegativity, and then inductive effect, then hyperconjugation, and then at the last we are going to deal with resonance, and this all we are going to cover up today only. But kids, we are going to start with inductive effect. That doesn't mean that inductive effect is most important. Yes, this is basic, and without knowing basic we can't achieve the resonance, and without knowing the basic we can't get sure success, just like 720 marks in your NEET examination. So what is basic? Inductive effect. To understand resonance we should have to have knowledge of inductive effect, kids. So before I'm going to start with GOC, I would like to say that analogy means atoms are like human beings and electron is like money. But all of these things I'm going to start, but these atoms, these electrons, I should start with. Before that, everyone smash the like button if you are regular students, and if you are new students, just subscribe this channel and then smash the like button. Kids, everyone, I want to see green signal from the chat section. As I was telling you each and everything, but I can see the green signal from the chat section. I want to see some fire, some thumbs up, some hearts for yourself, because today's GOC I'm going to definitely make it very big, large. Those candidates, those students who are unable to understand this topic, I will definitely let you know each and everything. Just sit with copy and pen. Whatever I'm telling you, kids, mark my words, each and everything is going to be really very important. Let me show you my homework. How much homework I have done. See, kids, let me show you these figures. See to it. I'm going to tell you, see how much homework I have done for you, kids. See, this is one figure. Just to save the time, kids, just to save the time. See how many diagrams I have drawn for you. Already I have made these diagrams for you, and see, kids, these are handwritten questions, quizzes, number of things I'm going to give you, kids. See how much homework I have done for you, kids, just to save the time, this much of homework. No, not only this much, see more, see how much, all these things I've done for you, kids. I will let you know each and everything with number of questions. Just if you like my homework, the whole day I have spent on this thing only, how to make you understand each and everything one by one with crystal clear each and every concept, kids. Now, let me go back. Let me go back and kids, see the mnemonic I have written. See the mnemonic I have written just to save time, just to save energy, just because your each and every minute is really very, very important. Now, kids, those who are new to this channel, those who are absolutely new to this channel, let me tell you, myself, Hareen Singh Parhyar, people call me HSP Baba, Magical Chemistry Guru. I have been teaching for last 23 years, produced number of rank, top 10 ranks along with mass selection. Yes, I have given number of ranks, but I'm not going to say these ranks are given by me. I was just the positive catalyst. It's all your hard work. If you're doing hard work, your success is waiting for you. Kids, number of doubts will be there, number of mistakes will be there, but with your hard work, you are going to get success. Now, what I say, I have been teaching for last 23 years. My degrees, if you talk about degrees, I have done MTech in 2004 and 1999 MSc gold medalist. Then after that, I cleared JRF and GATE examination. Now, kids, I'm going to start with general organic chemistry. Kids, you can see, like, share and subscribe. Once again, I'm telling you, if you're new to this channel, don't forget to, yes, subscribe this channel and hit the like buttons. Now, kids, one thing just remember, atoms like human beings and electron is like money. And I'm going to start. Now, kids, if I'm going to start with general organic chemistry, I would like to say that if you are having pen and copy, let us suppose this is your copy. Kids, this is your copy. And this is your pen. This is your pen. Just take the pointed side. Everyone just take the pointed side and hit your copy with the pen. Don't drop the pen. Just hit your copy with pen. Hit your copy with pen like this. Khatak. Hit your copy with pen like this. Have you done that? Have you done that? I want to see. Yeah, I will share the PDF. Definitely, I will share handwritten notes, each and everything. But just do let me know. Have you hit it? Yes, the copy. Now, just see on the other side of the copy. See the page. Everyone see the page with your hands. Just turn on the page. Everyone turn on the page. And on the other side of copy, just see the page is slightly displaced towards other side or not. I'm not saying it has gone torn. It has got torn. I'm not saying that, but it must have displaced a little bit towards other side, isn't it? Yes. Now, just turn on another page. See the second page. Just see the second page. It must be displaced, but not that much. A little bit less damage to the page. Page is remaining along with the page, but it has got little bit shifted towards more side, but less than the previous page, the first page. The second page effect is less. And now see the third page of your copy, even lesser. Now fourth page, someone, yes, is there someone? Anyone? Are you getting the effect? Some people must be getting the effect. Some people must not be getting the effect. Some people must be saying it's negligible. So I'm going to start with inductive effect. But before starting inductive effect, let me tell you the whole story. Let me tell you, kids, the whole story. If we want to start with any reaction, there is substrate. There is substrate. Now, what is substrate, kids? What is this substrate? Substrate means reactant. We used to say it is reactant. And in chemistry, there is reagent. There is reagent. What is reactant and what is reagent? Let's understand it. Reactant plus reagent, they are going to give you product. But question arises, what is reactant or substrate? The organic entity whose carbon, see, the carbon is the king over here. Carbon is the king, whose carbon is involved in reaction, Kids, everyone, just do let me know whenever you are going to deal with organic chemistry, who is the substrate, whether the substrate is written this side, whether the substrate is written on this side, wherever it is written, because the reaction takes place in one whole flask and flask is surrounded by like that, wherever it is written, then who is the reactant? The one who provides carbon during the reaction. Who is the substrate? Everyone say, the one whose carbon is forming the bond. Not, I'm saying just having carbon, whose carbon is involved in the bond formation. So reactant is always, it is always organic. It is always organic. Now who is the reagent? Reagent can be organic or it can be inorganic. Now kids, question arises, if this reagent is also having carbon involved in the bond formation, that it's possible that both can have carbon involved in the bond formation, just like Wood's reaction, Wittig reaction, Woods-Wittig reaction, then it depends, anyone can be called as the reactant. So this reagent can be organic or it can be inorganic. Just see to it, kids. See to it. If I say the reaction is taking place like this, C2H5OH plus PCl5, or I can write it like this, PCl5 plus C2H5OH. Either the reaction is written like this or the reaction has been written like that. Whatever the type of reaction is written, just do let me know who is the substrate in both the reaction. Is the substrate same? Substrate is same or different? Substrate is same or different? Do let me know, kids. Is the substrate same or different in both the two reactions? This is A, this is B. Everyone do let me know. I want to see in the chat section, is the substrate same or different in both the reaction? Do let me know, everyone. Same. Very good. I can see in the chat section that in both the reaction, substrate is same. This is substrate. This is substrate. Now kids, very good. Fantastic. Definitely your answer is 100% correct. Now kids, another thing, if I talk about, this is reactant, this is reagent, now this is product. Let me write down, this is product. What do you think? This reaction is taking place in one step or more than one step? So your answer can be, better to say, it can be single step reaction, it can be single step reaction, or it can be complex reaction. This is the point to be noted, my lord. Reaction can be elementary reaction or it can be multi-step reaction. Multi-step reaction, you will study in class 12th. Multi-step reaction takes place in more than one steps. Multi-step reaction, also known as complex reaction. Complex reaction. Elementary reaction is single step reaction. Single step reaction. Now kids, what I mean by saying all these things, when you go to school, some students may be going directly and coming directly back to home, but some students not coming directly from school back to home. They must be staying somewhere. I'm not saying what you are understanding, kids. I'm saying they are coming back from school and they must be buying some pen, pencil for 2, 3, 4, 5 minutes. They must be eating samosa, pizza for 10 to 15 minutes. But kids, I'm not saying like that. You are eating pizza for 5 hours. You are just buying pencil for 3 hours. No. You could spend your time in school 5 to 7 hours, back to home for many hours, but for buying pencil it just requires 5 minutes, 6 minutes, 7 minutes, 10 to 15 minutes. So these are known as intermediates, intermediate positions, intermediates. So kids, this complex reaction always proceed with the formation of intermediate multi-step reaction, and this is elementary reaction. And intermediates have very short lifespan. They have short lifespan. They have very short lifespan. And to understand the stability of these intermediates, we need the reaction mechanism. It's to understand the life of the stability of the structure of whatever the electrons they are having is known as reaction mechanism. Now see to it. If I talk about step by step understanding each and everything related to intermediates, step by step understanding of each and everything related to intermediate is known as mechanism of the reaction. Mechanism of reaction. And to understand mechanism of the reaction, two things are really very important. Two things are really very important. One thing is steric hindrance, steric factor, and second thing is being electronic factor. Now kids, two things. One is being electronic factor and second is being steric factor. I'm telling you each and everything from the very beginning, kids. Now steric factor is dealing with how bulky the atom or group is. How bulky the group or atom is. Okay, suppose you have bought one ticket and you are just moving from Mumbai to Goa, and one fatty person is sitting over there just in the neighborhood to you. Now you must be feeling uncomfortable because both the tickets are of same price. But if someone is very fatty, he must or she must be occupying maximum space. Nowadays in our country, still one person, one ticket. One person, one ticket. It's not tickets are sold on the basis of weight. One person, one ticket, right? So it all depends on how bulky the group or atom is. Electronic factors are of two types. One is permanent, another one is temporary. Another one is temporary. Now temporary effect is useless. This one is useless, kids. This is really the most important thing, and the whole study is based on this permanent effect, kids. Permanent effect. Now, if I say this permanent effect, how many effects are there which you can say permanent? So I would like to say resonance, hyperconjugation, inductive effect. These three effects are really very, very important. RHI. R means it's resonance. R for resonance. We can also say mesomeric effect. H for hyperconjugation. And I for inductive effect. And this temporary effect is electromeric effect. This is electromeric effect. Now kids, you must be thinking, what has happened to that thing? You have taken the copy and you asked to hit the copy. What happened to that? Kids, I'm coming back to the hitting of copy with the pen position. This inductive effect. So I'm going right now, I'm going to deal with this inductive effect. Kids, I'm going to deal with inductive effect. Now see to it, everyone. Inductive effect. Now kids, this inductive effect I'm going to tell you with your help only. You have to help me. No need to write down the notes, kids. These notes I will give you PDF in the form of PDF. But try to understand each and everything whatever I'm telling you. Kids, are you ready? Now everyone say, everyone, are you ready? I want to see your energy level in the chat section. Everyone, now the picture starts from here. Whatever I've told you, that was just the beginning. That was just the background. Now the movie is going to get started, kids. I want to see your energy level. I want to see the fire in the chat section. Yes, yes. Now see. You have to stay bonded with me, everyone, up to the last. Then only I'm going to tell you each and everything clearly, right, kids? Promise? Now, you have to make a photographic memory right now. It is just not the show. You have to understand, you have to keep each and everything in your brain. Then only you can solve the questions. Promise? Make a promise that yes, everyone is going to keep whatever I'm telling you. Each and every word is really very, very important. Don't say like that, I will revise it tomorrow. I will revise it day after tomorrow. Whenever the question paper is going to come, I will revise it. No. Right now. Right now. Everyone stop procrastination. Okay. Right now. Okay. Inductive effect. Now see. This carbon, 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 carbon. We all know very well your copy, your register is organic compound that is made up of pulp and paper. So, what you have seen, the paper got displaced, but paper has not torn. That means paper is still bonded with that portion which got shifted a little bit towards other side. Still the paper is bonded with rest of the paper. Am I right or wrong? Let me know in the chat section. Am I right or wrong? You have hit the copy with the pen. Paper got displaced little bit towards other side, but still Paper is bonded with the paper. Paper has not gone away from the paper. Paper has not torn out. Paper has not torn out. That means it is still having friendship, and this is known as sharing is caring. This is known as sharing is caring. Kids, this is known as sharing as caring. Now this, let us suppose this X element is more electronegative than carbon. Let's suppose this carbons, this is sp3 hybridized, so its electronegativity is 2.5. The electronegativity of sp3 hybridized carbon is 2.5, and this element X is more electronegative than carbon. Let us suppose this X is chlorine. Let us suppose this X is chlorine. The chlorine's electronegativity is 3.19. So if I talk about between these two atoms, who is being more electronegative? Who is being more electronegative, kids? X halogen is being more electronegative. So this shared electron must be more shifted towards that element side. So I have to draw it like this. That now the shared electron is spending more of its time with this X. Now this X is pulling the electron. Oh, electron. This is human being. I have told you X atoms are human beings. I have told you one thing, kids. Atoms are human beings. Treat atoms as human and electron like money. Once if you are able to understand this thing, atom like human being and electron like money, you need not to have any concept to understand. It will automatically come to your brain, automatically, kids. So this X is pulling electron towards its side. So once it is pulling electrons towards its side, it will develop delta negative charge because it has withdrawn electron. A little bit sharing of electron, 2 electrons, that electron got shifted more toward this side and it is having loss of electron. So this carbon will say, oh carbon brother, hey brother, give me some help me, my electron has been pulled by this X. Now I am feeling electron less, I am having less electron, please bhai, brother, help me out. So this will withdraw electron from this carbon and this carbon will withdraw electron from this carbon. Now after third carbon, kids, you must have seen your copy. After third page, in some students copy the effect is visible and other students copy the effect is negligible, and other students must be saying, sir, in my copy though after second page only effect is invisible. So kids, Peter Sykes of organic chemistry that writes up to second carbon it is valid. L.G. Wade is writing fourth carbon. Solomon writing third carbon. So scientists have taken all the data, and what scientists suggested, this effect is valid up to third carbon atom, and after that it becomes negligible. Everyone, are you able to understand, kids? After third carbon this effect is negligible. So I'm going to write after third carbon inductive fact is negligible. Why I'm saying negligible, kids? Why I'm saying negligible? You must have done prayer in your school. India is my country and all Indians are my brothers and sisters. How is it possible that all Indians are brothers and sisters? Then whom you are going to marry with? You must have done in your school. I was in KB. I've studied from KB. India is my country and all Indians are brothers and sisters. I was to sing except 2, 3 like that. How is it possible? How could it be possible that all Indians are brothers and sisters? As we go away, this brotherhood or sisterhood gets decreased. Now see, so one render mono. One render mono. After mono, this effect is negligible. One render mono. After mono, this effect is negligible. So, as the distance increases, this X is known as electron withdrawing group. Electron withdrawing atom or group. Atom or group. In short, we can say EWG. EWG. Everyone say EWG. We have to become familiar with these terms. EWG. EWG, WG, WG. Electron withdrawing group. The puller, electron puller. EWG is electron puller. Electron puller. Electron puller. Money puller. Money puller. Now, it has donated, so this hole is acting as electron donating group. Electron push, it is pushing. Electron pushing group. Now kids, this push-pull mechanism is done through sigma bond. This is always done through sigma bond. So this is withdrawing electron. You know tug of war. This is withdrawing electron. So it is having somewhat more electron. I'm not saying more one electron because it's partially shifted. There was sharing of one electron, kids. There was just a sharing of one electron. So out of one electron, suppose it has withdrawn 0.8 electron, 0.7 electron. So if any neutral atom is withdrawing electron, it will develop partial negative charge. So I will say this is minus I. Minus I. Why minus sign? Because it has withdrawn a little bit of electron. Electron has shifted toward this side, minus I, and this whole group will be known as plus I. Have you understood the meaning of minus I and plus I? Everyone just do let me know in the chat section. Minus I and plus I. The one who is electron donor is plus I and electron withdrawing group is known as minus I. Do let me know if this little bit very small thing, very basic thing is clear to each and everyone. Do let me know, kids. And this is operating through sigma bond. Now see, kids, let me write down what is inductive effect. See each and everyone. Inductive effect is the permanent effect. Permanent effect. What do you mean by permanent effect? What do you mean by permanent effect? Means no one is needed to do this effect. This effect is taking place by its own. No one is required, no reagent is required if sigma bond is there. So, inductive effect is defined as the permanent effect which operates through sigma bond. Sigma bond, do remember, it operates through sigma bond. And if there is pi bond, so definitely compound is not possible without sigma bond. Means pi bond, if there is pi bond, sigma bond has to have over there. Only there is one compound C2 which is not having sigma bond, and all are they being pi bond. Otherwise 99.99% cases pi bond can't exist without sigma bond. So it operates through sigma bond. Now kids, with increase in distance, inductive effect decreases, inductive effect decreases. With increase in distance, inductive effect decreases. Now, if anyone is asking, what will you say inductive effect? There is slight displacement of electron, or the electron is completely transferred. Electron is completely transferred or slight displacement. So, there is slight displacement of electron towards more electronegative atom, towards more electronegative atom. Now kids, if these points are clear to all of you, so let me tell you that in this world there are three types of things. One is being hydrogen. On standard scale, its inductive effect is taken to be 0, means neither electron donating nor electron withdrawing. It has been just taken as the reference. Just for the reference, they have taken it like that. Now, electron withdrawing groups, they are known as -I. They are just pulling electrons towards themselves. And electron donating group, they are known as +I. I hope this point is very much clear to all of you that mainly these are of two types, -I and +I, and this is 0. Just write down in the chat section, yes, you got it. There are, so you can say in this world, in our society, there are three kinds of people. You will say one, Mr. Mohan is neither taking our money nor he is giving money. Others, they are always asking, just give me this, just give me that. I want to eat this, I want to eat that. I want your car, I want your cycle. Please give me your pencil, give me your pen. And others, hey bacha, please have some sweet. Auntie log, just they are asking for, bacha, have some toffee, have some sweets. The world is like that. So the one who is giving sweet to us, the one who is taking our sweet, like this. Now see to it, kids. -I group, number of groups. This is the most important thing. The order of -I. I'm going to give you awesome trick. Once if you have good command on this, more, not only these many. See, A, B, C, D, E. 5 paragraph. I have divided it into 5 paragraphs. Everyone, are you ready? Now see, if you are ready, just see to it. Only the first line, they are having positive charge. Can you see? In the first line, they are having positive charge. Everyone see to it, positive charge. Positive charge. They are not having 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 positive charge. Only the first liner, they are having positive charge. See, we know that nitrogen is more electronegative. Its electronegativity is very high. Nitrogen, let me give you one trick for electronegativity. Let me give you electronegativity trick. Electronegativity. Fox call NBRI. NBRI, you know, National Botanical Research Institute. Fox call NBRI just to see Supreme Court hybrid plant. Fox call NBRI its electronegativity is 4, oxygen is being 3.5, chlorine is 3.1, nitrogen is 3. Now see kids, some books used to give chlorine and nitrogen's electronegativity like this and nitrogen's and chlorine's electronegativity like this. All three are correct. It depends on the circumstances and where they have been bonded. So all these three things are clear to all of you, that chlorine and nitrogen's electronegativity is somewhat near to each other. What code I have given you, what trick for electronegativity I have given you? Fox, call, NBRI, Supreme Court's hybrid plant. Fox, call, let me write down. Fox, fluorine and oxygen, two elements. Fox, call, NBRI, Supreme Court's hybrid plant. Supreme Court hybrid plant. Now kids, see to it. Now, so nitrogen's electronegativity is very high, but somebody has taken the electron of nitrogen. You are not able to understand. I think you are not able to understand. Just try to understand what I am telling you, kids. Suppose if I say this is Birappan, no, Birappan is no more, I know. This is, let us suppose, Birappan. Have you heard the name, kids? History Birappan. Right now, Birappan is no more, but long time back, Birappan. And this is normal person. So who is having more affinity for money? Who is more crazy about money, kids? Who is being more crazy about money? Birappan. He is always wanting to have money of others. Wanna money lover. Wanna money lover. Now, this is nitrogen. Suppose Birappan is nitrogen. Its electronegativity is 3. And this is carbon or something else. Anybody say? He has taken 1 electron, 1 lakh rupee from him. He has taken 1 lakh. He has lost 1 lakh rupee. This Birappan has lost 1 lakh rupee. Now kids, Birappan will be in normal condition, or he will be having some, some load of money, that my money has taken by somebody. I want to, he definitely wanting more money because he has lost money. So nitrogen is normal nitrogen once it is like that, and if nitrogen has lost electron, you will see that it is looking like that. Which nitrogen is being more electronegative? Kids, do let me know which Birappan is having more affinity for money. This normal Birappan or lost Birappan. Birappan lost 1 lakh rupee. So definitely answer is this nitrogen and this nitrogen plus. This is most electronegative. Means if its electronegativity is 3.0, then its electronegativity will be more than 3.00. Is this point clear to each and everyone, kids? So electronegativity of particular atom depends on the surrounding environment. It's not fixed. Electronegativity means my position is not fixed. It all depends on the circumstances. See, let me tell you. Let me tell you. First of all, let me write down what I said. Electronegativity depends on the surrounding atoms. Kids, let me tell you one thing. Suppose this is manganese. Manganese. You know that manganese is a metal. Kids, do let me know it is electron donor or acceptor. Electron donor or acceptor. Do let me know in the chat section. Donor or acceptor. If you're not participating in the chat section, you won't be able to understand electron donor or acceptor. Do let me know, kids, in the chat section. I want to see donor. It is electron donor. Now, manganese is being electron donor. It's not acceptor. So, this manganese was going and manganese mother said, you are donor. Kid, you are donor. So, donor have to donate. Manganese has donated electron to someone, +2. Manganese has donated more money, +3. Mama has given him 7 lakh rupees. Manganese mama has given 7 lakh rupees. How to know that how much money was given by mama? It depends on the group. To which group it belongs. It has donated money to someone. Then it has donated money. Then it has donated money, kids. Now, once all money he has spent, manganese 7, just like KMnO4. Now, kids, let me know this manganese 7 is electron donor or electron acceptor. Everyone, do let me know this manganese +7 is electron donor or acceptor. In the chat section, do let me know this is donor or acceptor. So kids, it all depends where and with what elements, what atoms that particular element is attached. Electronegativity is never fixed. It all depends on the surrounding atoms. If I talk about carbon, see, if I talk about carbon, this carbon sp3 hybridized, so electronegativity is 2.5. This carbon sp2 hybridized, so electronegativity is 2.75. This carbon sp hybridized, so electronegativity is 3.5. Kids, this carbon is even more electronegative than nitrogen, normal nitrogen. See, normal nitrogen's electronegativity is how much? Normal nitrogen's electronegativity is just 3, and its electronegativity is 3.25. So electronegativity varies with the bonding. Everyone is able to understand. Now see, kids, what I am trying to tell you, this thing, this is the trick. All they are positively charged. So the kid, everyone see to it. The trick is new positive friend, Narayan. New positive friend Narayan, along with Shahrukh, and positive charge Neha. Everyone say along with me, wherever you are seated, everyone say new positive friend Narayan. Once if you keep this thing in your brain, then only you can solve all the questions with feasibility, with spontaneity. Otherwise, always you must be searching these concepts in your copy only. Say everyone, new positive friend Narayan, along with Shahrukh and Neha. New positive friend Narayan. Just take the screenshot, everyone. Just take the screenshot, everyone, and say along with me. Just sing a song along with me. New positive friend, new positive friend, new positive friend Narayan. New positive friend, new positive friend, new positive friend Narayan. Along with Shahrukh and Neha. Along with Shahrukh and Neha. Once it is forming the photographic memory in your brain, then do let me know. Then only we are going to deal with the questions. If it is not clear in your brain, we can't solve the questions. Many people ask many times, how many times should I do the revision? Kids, do it once, just like Swami Vivekananda, but form the photographic memory. Don't do just for doing, and before the examination you are just trying to do the revision. Do it once, but for always. New positive friend, hey, new positive friend Narayan, 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 along with Shahrukh and Neha. Now, naughty Salman. Salman, to you know, Salman Khan. Naughty, 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 naughty Salman created scene. Naughty Salman created scene along with or in Rancho's car. Or you can say, naughty Salman and Katrina. CN. Katrina, you know Katrina? You know Katrina? Naughty Salman and Katrina in Rancho's car. Rancho, you know? Three Idiot movie, Rancho. Amir Khan was the Rancho over there in Three Idiot movie. So see, naughty Salman and Katrina in Rancho's car. Naughty Salman and Katrina in Rancho's car. Everyone say, naughty Salman and Katrina in Rancho's car. Or naughty Salman created scene in Rancho's car. Naughty Salman created scene in Rancho's car. If you don't know Rancho, if you don't know Katrina, then say naughty Salman created scene in aldo car. This is aldehyde also. You can say aldo car. Aldo car. Now you can say aldo, and this is carboxylic acid. Carboxylic acid. Naughty Salman created scene in Aldo's car. Done, everyone? Naughty Salman created scene in Aldo's car or Rancho's car. Is it clear to all of you? Now, friend call bro and I means mummy. In Maharashtra, I means mummy. Friend call bro and I. Alkoxy, hydroxy, ine, and Neha. See, this Neha is neutral Neha. See, neutral Neha. Without positive charge NH2. See to it, everyone. No positive charge over here. Everyone see to it. No positive charge at this place. And this Neha was having positive charge. See, positive charge. These two are different. It is on first position, the A category. This was the 8 category. That means this positive and positive H2 is having maximum minus I, and this neutral NH2 is having D category, not that much of minus I. Friend call bro and I, alkoxy, hydroxy, ine, Neha, Benz, Mercedes-Benz, in and hydrogen. It is there in your brain. Then we are going to deal with its application. Just to let me know in the chat section. Everyone, kids, do let me know in the chat section. Is it there in your brain? The minus I effect. All they are money lover. They are withdrawing electrons towards itself. All they are electron pulling groups. Kids, everyone, show me some sign in the chat section. Kids, you know how much hard work I am doing for you, so that everyone is going to the dream college. Kids, you are important and you will go to the dream college. But you have to mark my each and every word, kids. Do let me know. Okay, fantastic, fantastic. Now see, kids. See, kids. What is this? What is this? This is the most important thing where most of the students, they are going to make a mistake. This is the thing where most of the students, they are going to do mistake. This point, see, kids. This is the thing where most of the students, they are going to make mistake. Why this OR alkoxy is here and hydroxy there? This is the point to be noted, my lord. Let me give you the reason for it. See, reason for it. Electronegativity of central atom. Electronegativity of central atom. If the electronegativity is more, its minus I effect will be more. Electronegativity means tendency of pulling the electron towards itself side. Means you have seen tug of war. That means it's a powerful electron pulling atom. So see, kids, electronegativity of central atom, or you can say percentage of S character, is directly proportional to bond angle. Do remember your brain. This will definitely help you in your inorganic chemistry also. Which inorganic chemistry? That electronegativity of central atom or percentage of S character is directly proportional to bond angle. Now see, all of them, they are being sp3 hybridized. Why sp3 hybridized? 2 lone pair, 2 sigma bond. All of them, they are having all of them, they are having 2 sigma bonds plus 2 lone pairs. So what is the steric number, kids? 2 plus 2, 2 plus 2, 4. So all of them are being sp3 hybridized. This is being sp3, this is being sp3, this is being sp3. Now kids, if I talk about sp3, that one part of S and 3 parts of P, that it is supposed to be having percentage of S character just 25%. But kids, it all depends on bond angle also. When the hybridization is same, bond angle, you know, water bond angle is 104.5, alcohol is 109, and ether is 111. Do remember, because of balance electron pair repulsion theory, Basiper theory, balance shell electron pair repulsion theory, these atoms are being bigger. These R can be alkyl group or R can be aryl groups. They are occupying more space, so the bond angle got increased. It is 111 to 114 degree in ether case. In ether, this is being ether. In case of ether, the bond angle is maximum. So if you replace one H, it will become OR. You replace one H, OH. So you can see OR is more electronegative than OH. And this I have told you over here. This OR is being more electronegative than OH. This is being less electronegative. So this is the point to be noted, my lord. If once this point is clear to all of you, then we are going to reach towards plus I. See, this is clear to all of you. Is this page clear to each and everyone? Kids, do let me know. Kids, always show me some sign in the chat section. I want to see the chat section. Once the page is clear, always show me the thumbs up or some fire sign, or if you are able to see to it, if you are able to learn it, if you are able to understand it, show me some heart. By heart you have got it, kids. By heart you have got it. Once if you have got it, show me always some sign, kids. Now see, this is very, very important point. COOH. COOH. Kids, you must have seen fish. If you are having a fight with shark, if you are going to fight with shark, who is going to win? If shark is inside the water, then shark is going to win. If shark is on the land, you are going to win the race. You are going to win the match. It all depends on the medium. Any person or any animal is known by the place where it is present. As the medium changes, the strength changes. If you have seen movie Adipurus, the son of Ravana, Lakshman killed the son of Ravana inside the water because son of Ravana was finding himself weak inside the water. So it depends, all depends on which medium the thing is there. You have seen this COH and OH. Where you have seen this COH and OH? See, you have seen this COH and OH over here. You have seen this COH and OH over here. This is COH. This was under minus I. It was under minus I, COOH. You can see COOH was minus I. And OH, you have seen OH. OH was also minus I. Now kids, once they are present in basic medium, base, this is acid. This is acid. This is base. Acid-base neutralization. This OH negative will say, OH plus, I love you. I like you. I want to have your proton. Please give me your proton. I will snatch your proton. So proton has been lost in basic medium. COH will change into COO negative. This negative charge, now it is having extra electron. It is having extra electron. So it has become electron donor. It will get stability by donating electron. It will gain stability by donating. So it has become donor. It has become donor. So do remember, whenever COH is given in acidic medium, it's okay. Basic medium, it is not minus I, it is going to be plus I. So it all depends. If simply they have given you COH or they have given you COOH in acidic medium, so you will consider COH like COOH only. So minus I. But once COOH is given in basic medium, kids, in basic medium, just you have to say it is plus I. Kids, everyone is able to understand whether it is all about COOH, and the same thing, same will happen with OH. Same with OH also. Same with OH also, kids. Kids, everyone is able to understand. Now see to it. I'm going to tell you about positive I, plus I, electron donating groups. Electron donating groups. Now kids, once again try to understand it. CH2 negative, all those who are having negative charge, they are electron donating group. See, it's not OH, it is O negative, it is COO negative. I have told you, whenever there is negative charge, that means they are having extra electron. And once if they are having extra electron, they want to gain stability by donating electron. Let me tell you in detail one thing. Suppose this is a healthy, wealthy people without charge. Without charge means without charge. Without charge means healthy person. Healthy person means no disease. But if once this is having positive charge, that means suffering with disease, suffering with deficiency disease, deficiency. He was not having money, so he's suffering with disease like scurvy, rickets, osteomalacia, kwashiorkor, whatever the disease. And now kids, this was electron deficient. Electron deficient means money deficient, and that's why he's not having that much of money to eat. Now this A plus. Now kids, if he has eaten too much, he will have negative charge, means extra money he is having, extra money. So he is not doing any work because he is having extra money. So he is suffering with diabetes, mellitus, insipidus. So kids, if I talk about 1, 2, 3, who is most stable? This is having extra money, that's why he's suffering with disease. This people is having less money, that's why he's suffering. And this is healthy, wealthy without charge. Both of these are being with charge. So kids, do let me know, out of these three, who is most stable? In the chat section, do let me know whose first one is most stable, because this is without charge. So kids, always try to understand stability is inversely proportional to charge. Stability is inversely proportional to charge, whether this charge is positive or negative. Kids, the one without charge is most stable. The one without charge is most stable. And if both of the entity are charged, the one with less charge, as the charge decreases, as the charge decreases, stability increases. Agreed? Everyone agreed? Whether this is about element, this is about chemical, or we can talk about human beings, the human being without any disease is most stable. And if you are suffering with disease, as the disease decreases, stability increases. This is the great analogy, kids. Whether I talk about chemistry or I talk about the living human beings, whatever the things. So kids, this is clear to each and everyone. If it is clear, now let me come back. Let me tell you. So negative ones, they all are being plus I. And if you talk about O negative and CO negative, later on I will let you know this is stabilized by resonance. Stabilized by resonance. Now, more the alkyl groups, more will be plus I. Do remember everyone, more the plus I, for having more plus I, more number of alkyl groups are required. This is having 1, 2, 3 alkyl groups. This is having just 2 alkyl groups. And this is having 1 alkyl group. That is not having any alkyl group. And this is tritium, deuterium, hydrogen isotopic effect. Why is it like this? Let me tell you. Carbon and protium is bonded like this. Protium. Deuterium is bonded like this. And tritium is bonded like this. More the mass, do remember, more the mass, more will be electron donation. More will be electron donation. Less will be bond length. More will be stability. Now kids, whatever I have written, this is valid only for isotopic case, isotopic effect. They are being the isotopes. So this is valid only in case of isotopes. Is it clear to all of you? This is being protium, deuterium and tritium. So let's start the application of inductive effect, kids. Application of inductive effect. So we are going to deal with applications of inductive effect. There are total 5 applications: carbocation stability, carbanion stability, free radical stability, acidic strength and basic strength. Is everyone ready? Kids, Is everyone ready? Do let me know in the chat section that you are ready. How's the Josh? Once we are going to deal with these 5 applications, definitely we are going to win a big race. We are going to get adequate knowledge, kids. Is everyone ready? Do let me know in the chat section. Yes, kids, all of you are ready. Very good. Now see, let's start with carbocation stability. Now see to it. Carbocation. One name is carbocation, one name is carbonium, and one name is carbanium. Carbanium, according to IUPAC, if anyone is asking what it is called as according to IUPAC, so do remember, once this question has been asked in IIT, CR3 plus, CR3 plus, CR3 plus, where R can be hydrogen, it can be alkyl group, it can be aryl group. So this is known as mostly carbocation, carbonium, but according to IUPAC, this is known as carbanium. And see, one sigma bond, another sigma bond, another sigma bond, 3 sigma bond, and this is unhybridized pure p orbital. It is having 2 lobes, one lobe, second lobe. If say this is in the plane, if I say this carbocation, because when you are going to deal with SN1 reaction, SN2 reaction, you have to deal with this carbocation. Number of times you have to deal with this carbocation. If I say this carbocation is planar, like this, one valence is coming towards my side. Let me show you. This is one valency, this is one valency, and one valency is coming towards my side. See kids, one valency is coming towards my side. Triangular planar. See, trigonal planar. Trigonal planar. Can you see? So the p orbital is going above the plane and below the plane. This is pure p orbital. You can say unhybridized orbital with 2 lobes. One lobe is going above the plane, another lobe is going below the plane. Pure p per p or b. Pure p orbital perpendicular to the plane and lying above and below the plane, and this is being vacant, and it is in searching. It is in need of 2 electrons. So carbon with only 6 electrons in valence shell. Carbon is having what? In carbocation, carbon is having deficiency of what? Do let me know in the chat section. Carbon is having deficiency of electron as well as valency. Only 3 valency. Only 3 valency, kids. Only 3 valency. Only 3 valency. Carbon is supposed to be having 4 valency for complete octet. Not only the electron as well as the atoms in this world, atom as well as electron, both are required. So carbon with only 6 electrons in valence shell, electron deficient, electrophile Lewis acid. So it is searching for electron and the one atom having electrons. So see, once again I have drawn this structure, and one pure p orbital, one lobe is going above the plane, one going below the plane. So its steric number is 1 sigma bond, 2 sigma bond, 3 sigma bond. So steric number is 3 sigma 1 plus 0 lone pair. So 3, and 3 is sp2. So trigonal planar, pure perpendicular, and this all. Now see, if this is going moving like this, if I draw it like this, see, structure is like this. If sigma bond, and sigma bond is going like this, then p orbital will come towards your side. One p orbital lobe will come towards your side, one lobe will come towards my side. Or if I draw it like this, one p orbital lobe will go towards this right hand side, one will go towards left hand side. Everyone is able to understand, kids? Everyone, do let me know. Is everyone able to understand? Now see, kids, this is carbocation. See what a great figure I tried to draw. This is your carbocation, Mr. Carbocation, electron loving. So see, this is electron donor and this is electron withdrawing. electron donor, I can say plus I. This is plus I and this is minus I. And this is in need of electron. Need of electron means hungry for electron. Hungry for electron. So to whom it is going to love? The electron donor or electron withdrawer? It is withdrawing electron. It is donating electrons. So definitely this carbocation is going to show its love or attraction towards electron donor. That means for this carbocation, who is friend of this carbocation? Definitely electron donating groups. Rich entities are the friend of carbocation. Is it clear to all of you? Is it clear to all of you? That means stability of carbocation is directly proportional to plus I and inversely proportional to minus I. Kids, do remember. And if you're not able to keep it in your brain, just remember that carbocation is having what charge? Plus charge. You know that. A friend in need is friend indeed. Money begets money. Iron cuts iron, and poison cuts poison. So carbocation is having positive charge. So its friend is plus I. This is plus. So plus and plus are friends. So carbocation's friend is plus I. Is it clear to each and everyone? Now let's deal with questions. Now see kids. This is carbocation. This carbocation's friend, or you can say neighbor, is hydrogen. Hydrogen is saying, I'm to neither going to donate electron nor going to withdraw electron. So carbon is saying, oh dear, all of you three are a waste for me. You are not helping me. What type of neighbors you are? Now see, this carbon's one neighbor is, oh, I'm going to donate electron. I'm going to donate electron. So I'm going to donate electron to you. So this is giving electron to this carbon, and its charge plus charge, magnitude of charge is getting decreased. Magnitude of charge. Charge is like disease. Charge is like disease. Charge is like disease. Charge is getting decreased. Charge decrease, that means stability increase. Charge decrease, that means stability increase. Now see, this carbon's two friends, they are donating electron. So they are decreasing charge more, or they are distributing more charge, or they are responsible for dispersal of the positive charge. That means more charge is getting dispersed. So its charge decrease one much, its charge decrease too much. So stability increase too much. And now see, it's three friends, they are electron donor. So charge decrease three much. This too much is not of English. Too much is too much. In chemistry, I will say too much, three much, four much, five much, six much, like that. So try to understand. Now this carbocation, tertiary butyl carbocation, 3-degree carbocation, charge decreased too much. So stability increased too much. So 3 degree, then 2 degree, then 1 degree. If anyone is going to ask the stability order for carbocation, then 3 degree is more stable than 2 degree, then 1 degree. Everyone, till now everyone able to understand? Now I am going to deal with question. Now here is the question. Arrange the following in decreasing order of stability. Kids, arrange the following in decreasing order of stability. I want to see the answer of this question. Try to give me the answer, kids. I want to see the answer of this question. Everyone try to give me the answer in the chat section. I want to see kids. Everyone is saying 3. 3. Third one. Okay, let me check it out. Let me check it out. This is 3-degree carbocation. B, A, 2-degree. C, right. Absolutely correct, kids. Your answer is absolutely correct. Congratulations. Those who have got the correct answer, show me thumbs up. Now, another question, kids. Another question. Arrange the following in decreasing order of stability. Stability. Arrange the following in decreasing order of stability. What's your answer, kids? Another question. Another question. Now, once you are going to answer it, then I will explain. If your answer is wrong, then I'm going to explain it, kids. 1. Friends Gaming is saying 1. Piyush. Everyone, I want to see your answer, kids. DCBA. DCBA. Okay, let me check it out. This is carbocation. This is being the carbocation common to all, and these are the groups which are affecting stability. This chlorine is at this place, this chlorine is at this place, this chlorine is at this place, and there is no chlorine. So see, this is plus I, this is plus I, this is going to be the most stable. D is going to be the most stable. After D, it is far away. See, this carbon is positive charge, then 1, 2, 3 at third carbon, 1, 2 at second carbon, and first carbon only. This is distance is very near, so it is electron withdrawing group, kids. It is withdrawing electron, and it is withdrawing electron. That means charge is increased 3 much, so stability decrease, stability decrease 3 much. Then here charge increase too much, stability decrease too much, and here too much far away, so charge decreased 1 much, decrease, no, increase. Here charge increased 1 much, stability decreased 1 much. So DCBA, no, DA, DA, then B, then C, kids. DABC, DABC, no option. O, D, A, B, C. So this is the answer, correct. No option is matching, kids. So let me make it D, A, B, C, D, A, B, C. Now first one is correct, kids. Is this your answer, kids? Let me know. Let me know. Now those who have got the correct answer, show me the thumbs up, everyone. Everyone, kids, show me the thumbs up now if your answer is correct, because all the options were given to be the wrong. All wrong options were given over there. So yes, you are really genius. Another question. Another question. This is really simple question. I hope that everyone can do it. I hope that everyone can do it, kids. This question can be done by each and everyone. Yeah, it's a grace mark, you can say. So now I want to answer. I want to get the correct answer, kids. Do let me know, everyone. See, all they are having carbocation at this place, carbocation at this place, and the affecting group it is located at this position, it is located over here, it is located. So enemy, the chlorine is enemy or friend of this carbocation? Just to let me know, is it enemy or friend? Enemy or friend? This chlorine is being enemy, so enemy is far away and this enemy is closest. Enemy should remain far away or enemy should present nearest to you? Kids, do let me know, enemy should remain far away or should be present nearest? So this is far away. A, B, C, D. A, B, C, D. No option. Oh my God. No option is given over there. So let me write down A, B, C, D. No option was given like that. A, B, C, D. So this is going to be the correct answer. So kids, what I did, I have given options like that. You should get trapped in those options, but you are not getting trapped. Kids, the most important thing is that I have given the options like that because I have designed this paper and I have given options like that. You should get trapped in these options, but you are not getting trapped, kids. You are not getting trapped. Wow, really awesome, kids. Now another question. Oh, this question is really awesome. Now see to it. This is carbocation. This carbocation is suffering with charge, and these are the groups which is going to affect its stability. 1 chlorine, 2 chlorine, 3. Oh, 3 enemies. 2 enemies, 1 enemy, no enemy is over there, no dushman is there, kids, no enemy. The one without enemy is most stable. The one without enemy, DCBA. How many of you got the correct answer? Show me the thumbs up or the hearts. I want to see the fire. I want to see the chat section to be colored. Now, this question is that not toughest, I will say a little bit tough question. This question is little bit tough. So try to give the correct answer, kids. And kids, sit with plenty of water. Everyone sit with adequate amount of water. See, I'm having this much of water in, you can say mud pot, right? I'm having this much of water. Everyone keep yourself hydrated. Now see, this is the sufferer. It is having positive charge and these are the affecting groups. So all these are enemies. This is friend, this is plus I, it is friend plus I, and all these are being enemies. So this friend D must start from D. Then this is the powerful enemy, most powerful enemy. How to find out this is most powerful enemy, kids? How to find out this is most powerful enemy? That its minus I effect is maximum. So it will withdraw the electron and it will intensify the charge. Maximum charge will get maximum intensified. Maximum intensified. This is the clear English, or you can say charge is increased very much, 3 much, charge increased 2 much, charge increased 1 much, charge decreased 1 much. So if the charge is increasing, stability is decreasing and charge is decreasing, so definitely stability is getting increased, stability increasing, and here the stability is getting decreased. So your answer is 100% correct. Stability is getting decreased. Now kids, DCBA, your answer DCBA is absolutely correct. I hope everyone is able to understand. Everyone is able to understand DCBA. Now another question. Now this question is toughest question. I would like to say this question is not easy question. This question is not an easy question. Everyone try to answer it. This question is not easy question, kids. This question is not easy question. Sir, for making our earning strong, what steps should be followed? Just follow whatever I am teaching you, kids. Everyone try to understand just to make organic chemistry powerful, up to mark, rank boosting. Just follow whatever I'm teaching. I'm teaching from zero level, kids. I'm teaching from zero level. Now see, kids, what's your answer? Do let me know, everyone. Some are writing 4D. Okay, let me check it out. This is CH2 plus, CH2 plus, CH2 plus, CH2 plus. Here, NO2, most powerful enemy, most powerful enemy, weak enemy, weak enemy, two enemies, two enemies, two weak enemies, two weak enemies, and this is being friend. So definitely this is being friend. Most stable is this D1. D1 is most stable, kids. Now what do you think? A powerful enemy is far away. Powerful enemy, but far away. See how far away? Powerful enemy, 1, 2, 3. Far away. Powerful enemy, but far away. Far away. And this is weak enemy, but too much closer. Weak enemy, but too much closer. Why? Who is more? Who is going to destroy us? Who is going to ruin us? Who is going to give more pain to us? A weak enemy nearest to us, and the powerful enemy who is far away, who is more, who is going to affect more. Kids, who is going to affect more? DACB. So for such type of questions, do remember one thing. For such type of questions, do remember one trick. One trick I am going to give you, kids. Trick. Whenever there is problem in such type of questions, always follow the trick. Trick is doctors and patients. Doctor and patients. What's that? What's that? DNP. What's that, kids? What's that? DNP is what? First number. Always follow distance. Whenever there is distance, number, then power. How's the trick? Distance, number, power. DNP, DNP, DNP. Hey, DNP. DNP, DNP, DNP. First give preference to distance. First give preference to distance. On first number distance, second number number, and third number power. DNP, DNP, DNP. Have kept it in your brain. Whenever there is problem in such type of questions are there, always give preference DNP. DNP is really very important. Now let's see to it. DNP, let's apply DNP. Let's apply DNP. Now see, kids, this is the most stable. Now this distance is least distance, so it is going to apply most minus I, so the charge is maximum. Once the charge is maximum, because its distance is very less, so its minus I is most effective. Minus I is going to be most effective, so charge is maximum, so stability is least. Agreed or not? And distance, now see, 1 2 3, 1 2 3, both are in 3 position. These are 2 in number, that is only 1. Distance number, its number is more, so its charge is, that was 4, let us suppose its charge is 3, and stability will get decreased 3 times, and let us suppose its charge increased 1 times, so stability decreased 1 time. So most stable is D, then A, DA, then C, then B. Wow kids, DACB, fourth option. This was the toughest question. Everyone, those who got correct answer, show me the thumbs up, and if your answer was wrong, show me the thumbs down. This was really awesome question kids. Really awesome question kids. If your answer is correct, kids, do let me know everyone. Once your answer is correct, show me the thumbs up. If your answer is wrong, show me the thumbs down. Really awesome question. Now, doctors and patients, DNP, or you can say doctors new practice. One more trick is there, doctors new practice. Doctors new patient or practice. Now see kids, one more question. Just try it out and let me know. Break by 8 p.m. please. Yeah, I will give you break, but short break, okay? Short break I will give you definitely. I will give you a very short break, kids. I will give you a very short break, kids. Now, kids, what's the answer of this question? See, this is the carbon with positive charge. You can see carbon with positive charge. You can see to it, carbon with positive charge, carbon with positive charge. And the groups, you can see the groups. This 3 groups plus I, 3 groups which are applying plus I, but distance is 1 2 third carbon they are. Now this is present 1 2, only 2 groups, but at second carbon. Now this is minus I, they are plus I, this is being minus I, but it is present 1 2 3 at fourth carbon, and these are 2 groups minus I, and they are present at second carbon only. So who's being most stable, kids? What's your answer? Let me check it out. What's your answer, kids? Fourth. Wow, let me check it out. This is going to be the most stable. B is going to be the most stable. B is going to be the most stable, kids. B is going to be the most stable. B. After B, A. After B, A, because they are stabilized by plus I. Then minus I, the number is more, power is more. Here power is more. Here power is more. Here number is more and distance less. Number is more. So it is increasing the charge. It is increasing the charge. And it is increasing less charge. It is decreasing the charge. It is decreasing the charge. Everyone is able to understand. These two are decreasing the charge. These two are increasing the charge. So D will be at the last. BACD. BACD. So fourth answer, kids. This is once again a rank deciding question. Once again, it's going to be rank deciding question. Those who have got correct answer, kids, those who have got the correct answer, do let me know in the chat section by showing thumbs up. Otherwise, thumbs down. Thumbs up, thumbs down. Now, carbanion, the second application is carbanion. Now, let me tell you about carbanion. Then we are going to solve questions based on carbanion. Now, see to it, everyone. Carbanion. Kids, in carbocation, carbon was having positive charge. But in carbanion, carbon is having negative charge. That means the carbon is having extra electron. Now you will say, sir, how extra electron? Carbon is to having only 8 electrons in the valence shell. Then how extra? Question arises that we have studied if carbon is having 8 electrons in the outermost orbit, its octet is completed and everyone is stable once their octet has been completed. Then what's the problem? There is one problem. See, what's the problem? See, the problem over here is, let us suppose this is carbon. Atomic number 6. Mummy has given 4 electrons to spend. These 2 lakh rupees in FD. FD, you understand? Fixed deposit. Not available for spending. Fixed deposit in the bank. You know fixed deposit? These 2 lakh rupees are in bank. Mama has given 4 lakh rupees. Just go and share. Just go and complete octet and complete your octet. Now kids, what this carbon has done, carbon was having 4 electrons in the outermost shell, that is valence shell, and it has formed a bond. Like it has formed a bond with hydrogen. 1 electron sharing, 1 electron sharing, 1 electron sharing, and 1 electron sharing. Now, with 4 hydrogens, it has formed the bond. Now, carbon's octet got completed. Now, carbon is having 8 electrons in the valence shell. One day, what happened? Now, right now, carbon is having 8 electrons in valence shell. He was happy. But one day, what has happened? This carbon has taken 1 electron of this hydrogen. They were sharing of electron was done, but this carbon has gained 1 electron of hydrogen and thrown out this hydrogen out. So this carbon has gained 1 electron. So this carbon is having 1 electron of hydrogen. Now its octet was there completed. Here it was having 8 electrons. Here also it is having 8 electrons, but its nucleus is not able to hold that electron. Its effective nuclear charge got decreased. These 2 electrons were bounded by these 2 nuclei. 2 nuclei were holding 2 electrons. Here 2 electrons are held by only, or you can say 1 nuclei is applying force of attraction. So less force of attraction on this electron. So this electron is more free. Extra electron is more free. More free. So unstable, or you can say this is without charge. I have told you without charge one is more stable. Without charge is more stable than the one with charge. This one is charged. So the problem is of valency. Here the valency is 4 valency. Here the valency is just 3 valency. So the problem is of 3 valency. less valency. This is the problem over there. That's why this is being unstable. So see kids, carbanion having 8 electrons in the valence shell, 8 electrons, but the valency is 3 only. Only 3 valency. Only 3 valency kids. So electron rich entity, Lewis base. So we can say this is the rich person, rich family, and wanna donate electron. Wants to donate electron. Why it wants to donate electron? It is having extra electron. So all the carbanions, by donating electron, the charge gets decreased. So one thing must be very clear in your brain, that all carbanions gain stability by donating electron. What I'm saying, once they are donating electron, by donating electron, their charge decreases, and stability increases, I hope this point is clear to all of you. Now see, everyone, this so already I have told you. Now see, this is carbanion. This is lone pair of carbanion, lone pair. This is 1 sigma bond, 1 sigma bond, 1 sigma bond, 3 sigma bond, 1 lone pair. 3 sigma bonds plus 1 lone pair, that become 4, and the hybridization is sp3. Agreed? So because this valency is not there, structure is similar to somewhat like ammonia, pyramidal shape. It is pyramidal shape. Now kids, this is having extra electron, 1 extra electron. Kids, do let me know, it will attracts, it is going to attract the electron deficient one or electron rich one. Do let me know in the chat section. It is going to attract the electron deficient one, that is minus I1, or it is going to attract electron donor one, that is plus I. It is already having extra electron. It is, you can say, rich will love beggar or the rich. So definitely this is having negative charge. So it loves electron deficient, that minus I groups, they are their friends, and it hates electron donor, that is being plus I group, that they are being the enemy. Now if you are not able to find it out, who is the enemy, who is the friend, let me tell you kids. Let me tell you who is the enemy, who is the friend. If I talk about carbocation, if I talk about carbanion, if you're not able to keep it in your brain, just see carbocation. What is the charge in carbocation? Cr3 plus. So who is the friend? Plus I. Plus charge, plus I is the friend. Plus charge, plus I is the friend. Now carbanion. What is the charge on carbanion? Cr3 negative. So who is the friend? Negative I. Is it clear? If entity is having positive charge, plus I is the friend. If entity is having negative charge, minus I is being the friend. Is it clear to all of you? Are you able to get it? Everyone, are you able to get it? Now see to it. Kids. Stability of carbanion is directly proportional to minus I electron withdrawing group and inversely proportional. This is directly proportional to minus I and inversely proportional to plus I. So stability of carbanion depends on minus I groups. Once there are minus I, they are going to increase its stability. So this is the carbanion. So carbanion loves minus I and hates plus I. Plus I1 are electron donor. and minus I are being electron withdrawing group. Electron withdrawing group. Now kids, see to it. Once again, these are the structures: tertiary butyl, isopropyl, ethyl and methyl. So we have seen same structures in plus I application. Once again, these structures are in front of us, but see to it, everyone see to it. This carbon is suffering with diabetes. This carbon is suffering with diabetes, and this hydrogen is saying, oh, I'm not going to give you any sweet or nothing. I'm going to give you chocolate, toffee. I'm not going to share. Now, this methyl is saying, oh dear, I'm to electron donor. I'm to plus I. I will donate electron, and will increase your charge. Once the charge is increasing, kids, charge is increasing, charge increased, then stability decrease. Now here to two methyl groups, they are applying plus I. That means they are donating electron and they are intensifying the charge. Charge got intensified means same thing. Either I can write charge increase, or I can say this is what? Charge increase 1 degree. It was written there 1 degree, and this is being 2 degree. Charge got intensified. Both means same. Intensified, or I can say charge increased, stability decreased. Now three methyl groups, they are donating electron, so charge increased maximum, so stability decrease. So I will say 3 degree, then 2 degree, then 1 degree. Who is going to be more stable, kids? 1 degree is going to be more stable. So it is just opposite to plus I. In plus I, that was more stable, but in minus I, this is the stability order, kids. Is it clear to all of you? That on moving from left hand side to right hand side, the stability of carbanion is increasing. Carbocation 3 degree was more stable, but carbanion 1 degree is being more stable, and 3 degree is going to be least stable. Now see to it, kids. See to it. Here are the questions. Now it's your turn, kids. Let me know what's the answer. Let me know the answer, kids. I want to see your answer for this question. Everyone try it out. I want to see your answer, kids. Fast. Hurry up. Fourth. Okay, let me check it out. This chlorine is present at this position, this at this position, and this is the enemy. This is the enemy of carbanion because it is applying plus I. So most stable is CBAD. Yes, your answer is 100% correct, kids. Your answer is 100% correct. Those who have got the correct answer, do let me know in the chat section that yes, you got it. Very good. Kids, I want to see thumbs up once your answer is correct. Now, here is another question. I want to see your answer. Can you see, kids? Can you see how much hard work I have done? How much hard work is done by your HSP, Baba? Can you see, kids? Can you see? Number of questions, they all are being new questions. All of them are being new questions. I have shared with you, and I will definitely share the PDF also, and these questions are framed by me, and these are absolutely new questions, kids. First, everyone is writing first. Now see, this is friend minus I because minus charge, so minus I, and number is DNP, doctor's new practice, doctor's new distance. Distance is, see, everywhere distance is same, 1, 2, everywhere distance is same, so no problem of distance. 1, 2, 1, 2, 1, 2, 1 2 1 2. So we have to see distance is same, so we have to see number is 3 2 1, 3 2 1. So A B C D, A B C D, first is the correct answer. Definitely your answer is absolutely correct. Congratulations to each and everyone. Now next question, another question. Kids, do let me know what's the answer of this question. Everyone, do let me know what's the answer of this question. I want to see your answer, kids. Yes, yes, fantastic. Maximum students, majority of the students, they are marking. Fantastic answer is given by these students, and they are following the rules and regulations. They are just showing in the thumbs up that the chat comment section, they are just marking the correct answer, and I can see that the answers are correct because the chat section is running fast with all of your answers. Fantastic. Now let me see. 1 2. This is maximum power than naughty Salman in Rancho Scar fluorine phenyl. So this is going to be A B C D. A B C D. So it's the power rule. Distance is same, number is same. So it is all being decided by power. Power. This is all decided by power. So this question has been done by power. Power of minus I. Power of minus I. Absolutely correct, kids. Absolutely correct. So another question. See how many questions, variety of questions, number of questions you're going to get, kids. Break I will give you at 9. At 9 I will give you the break, kids. At 9. At 9 I will give you break. Just to let me know, kids. Okay. Now see. This is negative charge. 1 2 3. This is having maximum power, but at third carbon. Carbon is 3. Third carbon. Now see, number is 1. Only 1. One friend. This is the friend of negative charge. Only 1. These are 2. Weak friends, but 2. And distance is just on the first carbon. 1 2 3 4. Maximum enemy, and distance is too much, but these are just 2 enemies. So these are enemies. We have to find out which is enemy, which is friend. So enemy. Why these are being enemy? Negative charge, and these are plus I. Plus I. Negative charge, these are also plus I. Plus I. So they are enemy. Negative charge, and they are being minus I. If you know what is being minus I group, which is being plus I group, then you can definitely. So we have to follow D and P. D and P. See, these are nearest. Distance is less, number is more. Distance is less. Distance is less and number is more. Number is more. And this is enemy of friend. This is being friend. This is being friend. So kids, friend's distance means friend is nearest. Friend is being nearest and more in number. So this is going to be the most stable. B. B A C D. BACD is the correct answer. BACD. Which option? BACD. Fourth option. Kids, how many of you got the correct answer? BACD is the correct answer. Wow. Wow. One kid is writing Namma channel. Namma means what? Kid, I'm unable to understand Namma channel. Namma means what? Kids, let me know what is the meaning of Namma. Namma means what? Namma channel. Namma means good or bad. So Namma means, oh, our channel. Okay, okay, kids. Wow, really awesome. Meaning is our channel. Yes, it's your channel only. That's Unacademy NEET English channel. And definitely, kids, it's your channel only. It's your channel. Yes, better to say it's our channel. It's our channel because we are also there. So it's our channel. Yes, it's our channel. Now, kids, before moving ahead, kids, do let me know my speed is okay, my teaching is good, my examples are good, I have framed out new questions. Are they good or not? Kids, do let me know because after a very long period of time, this is the first class. After a very long time, I'm taking this class and we are taking this class. So it's always better to know how much you are liking. From my side, I have tried my level best, but from your side, do let me know that how much you are liking the class. Kids, in the comment section, in the chat section, do let me know that how much you are liking this. Absolutely perfect. Thank you, kids. Thank you. Really, it means a lot. See how much efforts I have added over there. I put there really lot of my time so that I can save your time. See, kids, still number of questions, handwritten questions, so that they should be error free. Thank you, kids. Thank you, kids. Thank you. Now see another question. Oh, let me make another question right now. Let me make another question right now. Now, who is being most stable? Options may be getting matched or not getting matched. I don't know. But what's your answer? So I think let me make the options also. Yes, kids. What's your answer? C A C A B D D B A C C B A D C B A D. So let me check it out. It is carbanion. Kids, it is being carbanion. Definitely it is being carbanion. So who is the friend of carbanion? Minus. So just see the distance. Just focus on distance. 1, 2, 3. This is on third carbon. 1, 2, 1, 2. This is on second carbon only. This is even more powerful. I would like to say it is most powerful. Most powerful. But what's the difference or difficulty is there? Most powerful. Its power is maximum. It is most powerful, but gets distance is maximum. Distance is maximum. Distance is maximum, and number is only one. And number is only one. Number is only one. This is the problem. Number is only one. See, this is less powerful but nearest, and these are two in number. Distance is same in between these two. In between these two, distance is being same. Distance is same, but in this two in number, these are two in number. So just apply DNP, doctor's new practice. Distance is equal, but number is more. Number is more. So this is more stable. C. Then CBAD. CBAD is the correct answer. How many of you got CBAD, kids? This was really awesome question. If you got CBAD, that really means a lot, because these type of questions, doctors new practice, they are going to give you rank, maximum marks, each and everything. Now see kids, now this is all about carbocation and carbanion. Now we are going to deal with third application. We are going to deal with third application, and third application is free radical stability. Free radical stability. Now what is free radical? Free radicals stability. Now kids, let me divide free radicals in two categories. CR3. Could you please help me to know what is the hybridization of CR3? What is the hybridization of CR3? Kids, this CR3 is being sp2 hybridized. But do remember, it is sp2 hybridized when R is equal to either hydrogen or alkyl group or aryl group. But if R is halogen, then it is going to be sp3 hybridized. If it is like this, its shape will be trigonal planar. But if it's like this, it is going to be pyramidal in shape. Now kids, why is this? The difference is there. Let me tell you kids, first of all, about this. If I talk about carbon, its 3 electrons are shared like this. One electron, and in sharing, suppose this is R group, one electron shared, one electron has been shared. Now 6 electrons, and plus, if I talk about this orbital, now this carbons, these electrons, they are too much closer, and this electron, there is repulsion. Due to repulsion, this electron will go far away. Which electron? Due to repulsion of these 6 electrons, 2 electrons, due to repulsion by 6 electrons, this free radical will go far away. This free radical will go far away. That means not the part of this group, means not hybridized. Far away means kids, far away means not hybridized. So see kids, these 3 sigma bonds are hybridized. I would like to say only these 3 sigma bonds are hybridized. 1, 2, 3. 3 sigma bonds. So steric number is going to come out. Steric number will come out. 3 sigma bonds plus 0. Nothing is there. That means 3. And this is being sp2. I hope this much is clear to all of you. So the shape is trigonal planar, and this is pure P per P or B. Pure P per P or B means not the hybridized, the vacant. I will not say vacant because it is having 1 electron, free electron. Neither it is vacant nor it is fully filled. It is still having 1 electron. Okay. Now see kids, if I talk about halogens, If I talk about halogens, so see kids, halogens, let us suppose about chlorine. So chlorine is more electronegative than carbon. It will take its electron nearest to it and it will withdraw electron of carbon also. Now once the carbon is losing, I will not say losing, carbon's electron have been gone far away. That means these six electrons have gone far away from this carbon. Now this carbon is in need of this one electron. It is used to say that old is gold. So these these six electrons have gone far away from carbon, so there is no repulsion by these electrons on this electron. So I will say, or anyone can say, this electron is feeling less repulsion. This extra free electron is feeling or experiencing less repulsion. So it has become the part of the group. So it got hybridized. So got hybridized. And now we will say the steric number got changed 3 plus 1. This free radical 3 plus 1, that is being 4, and this is being sp3 hybridized. So the shape is pyramidal shape. I hope kids you are able to understand. So whenever somebody is asking what is the shape, what is the hybridization of free radical, it depends. Generally it is sp2 hybridized. If anything is mentioned like halogen, then we will say yes, sp3. If nothing is mentioned, we will say better to say sp2 hybridized. Now see stability order. Let's talk about the stability order of it, kids. Stability order of it. Let me talk about the stability order of it. Just wait. Just give me a second, kids. Now see to it, kids. Stability of free radicals. Third one, stability of or stability order of free radicals. Now kids, if I talk about free radicals Cr3, one electron, how many electrons do carbon is having in the outermost shell? Do let me know. This carbon is having how many electrons in the outermost shell? 7 electrons in the outermost shell of carbon. See kids, this free radical is having odd electron species. We will say it is odd electron entity. This being odd electron entity, but without charge. Highly unstable, but without charge. Better to say this is highly unstable, but no charge, It is not like carbocation, carbanion. Carbocation was having positive charge, carbanion was having negative charge. This is not having any charge. This is free radical. Now see kids, If I draw these structures, if I write like this, CH3, 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 this is electron deficient with three friends. How many carbons are attached with this? 3. So the degree is 3 degree free radical. Now if I draw like CH3, CH3, H, only 2 carbons are joined. So I will say it is being 2 degree, only 2 friends. Now if I draw like this, CH3, H, H, only 1 carbon is attached, 1 degree. And this is the methyl super 1 degree. Now kids, what will you say? Who is being most stable? So 3 friends are donating electrons, 3 friends. So this is most stable. Then 2 friends, this, then this, then this. So in free radical case, the stability is just like carbocation, 3 degrees most stable, then 2 degree, then 1 degree. This is without resonance. So this is the stability order of free radical. Now kids, 2 applications. One is being acidic strength, one is being basic strength, really the most important. Now just to let me know, because acidic strength and basic strength, they are really very important, and to understand them means better to say acidic strength, or this is really, it is going to hold a hell lot of weightage, very important, and maximum questions has been asked in most of these exams from here only. So do you have energy? How is the Josh? I would like to see. Let me have a glass of water. You also keep yourself hydrated, and then I'm going to let you know the most important thing, the acidic strength. Fourth application, very important kids, acidic strength. Acidic strength. What is an acid? What is an acid? RCOOH. Most of the time you must have seen people used to say acid is one who donates its proton. You must have seen people must be saying the acid is one who donates its electron. Its acid is not one who donates its proton, but actually its proton is snatched by the medium. See the difference. If you're saying the acid is entity who is donating its proton, what I'm saying, it's not trying to donate its proton. Its proton has been snatched by polar protic solvent, PPS. It can be any polar protic solvent, polar protic solvent. Is there any difference what I am saying and what you people always see? An acid is a entity, is acid is an entity which donates proton, one statement, and acid is an entity whose proton is snatched by medium. This medium, aqueous medium, this is going to snatch its proton. Now people, you must be thinking, what's the difference, sir? What's the difference in both of these two statements? See kids, if it is going to donate its proton by itself, it will get negative charge. It will get negative charge. Get it? Can you see who is more stable? The one without charge or the one with its negative charge or positive charge? This neutral species, neutral entity is being more stable. Neutral is more stable than the charged one. But then also it got formed, and it is forming an equilibrium because its proton has been snatched by the medium. And kids, this reaction moves in the forward direction as well as it comes in the backward direction, because organic acids are weak acids. Organic acids are weak acids. Organic acids are weak acids. Now kids, this is unstable because this entity is being charged. Entity is charged. So unstable. So unstable. This entity is charged, so unstable. Better to say, if this is an acid, that is going to be its conjugate base. This is going to be its conjugate base. Now kids, even I can talk like this. The acid, I can talk like in another direction. I can talk like this. See kids, if I say this is an entity RCOOH, this is one human being. See to it what I am talking. This is one human being. One human being. And the season is of winters. Winter season. And this is the jacket. He is wearing out jacket. And somebody came just like, who is that somebody, like water. Hey water, how are you? This is suppose water. Water is saying, oh, I'm feeling very cold. This water is saying, oh, I'm feeling very cold. I want your jacket. And water says, I will take your jacket. Whatever the time is required, that doesn't matter. But I will snatch your jacket. I want your jacket. I want to get your jacket. And this water solvent will snatch the jacket of this. And he tried a lot, but he is unable to protect his jacket, and he has lost his jacket. And now he is suffering with terrible cold without jacket. So with jacket he was more stable. Without jacket he is being less stable, more stable, and the conjugate base is being less stable. Kids, are you getting my points? Are you able to understand the analogy what I am going to tell you? Or you can say this is the man and this is the, you can say, medicine, and somebody has stolen his medicine and the patient is without medicine. Or you can say this is army person and this is, you can say, his AK-47 or pistol. Now the man is without pistol and somebody has snatched the pistol of that soldier. Now soldier is without pistol. Are you able to understand, kids? Do let me know in the chat section. Are you able to understand what I am trying to tell you? Now kids, if I compare this and that, if its conjugate base is found to be more stable, then it is less need of this proton. If conjugate base is more stable, then it will be in less need of this proton, and this will not go more in the backward direction. And if anyone's entity's conjugate base is being less stable, then it would like to accept proton and it would like to show its more tendency in the backward direction. Everyone, now see, let me compare. Kids. See, if I write two acids, see to it everyone. Let me write down two acids and their conjugate bases. Acids and conjugate bases. Let me write down first acid as acetic acid, CH3COOH. This two acid you know very well. And another one is being nitroacetic acid, NO2CH2COOH. Both are being aqueous medium. Aqueous means water. Just see to it, water is there and water has snatched their proton. Both have lost their proton. Now without proton, you can see it will look like this CH3 COO negative, and it will look like this: NO2 CH2 COO negative. Now kids, if I say this is being first acid, this is being second acid, and this is A conjugate base, and this is B conjugate base, could you please let me know which conjugate base is being more stable? Out of A and B, which conjugate base is being more stable? Could you please help me out? Kids, I want to see, I'm just watching your chats. Which conjugate base is being more stable? A or B? B, everyone. Because you see, it is just like carbanion having negative charge. Negative charge means friend is minus I. If any entity is having negative charge, then the friend will be minus I. If any entity is having positive charge, then the friend will be plus I. So this is negative charge and friend is minus I, and this is plus I. You see plus I. What is the difference in between these two? This plus I is donating electron, electron donor group, electron donating group. So the charge is increased, and the charge is increasing, its stability is getting decreased. Stability is decreasing, its stability is decreasing, and the conjugate base stability is decreasing. It would like to accept proton, and it would like to go more in the backward direction. It would like to go more in the backward direction, kids. Definitely it would like to go more in the backward direction because it is feeling highly unstable. But kids, here you can see this minus I group is electron withdrawing group. This is just withdrawing the electron minus I. So the charge is intensified, or you can say in normal language, charge is getting decreased, and the charge is decreasing, stability is getting increased, and stability is increasing. So it will come in the backward direction, but not with that much extent. So its equilibrium is lying more in the backward direction, more in backward direction. Its equilibrium is lying more in backward direction, and its equilibrium is going more in forward direction, So this is being more stable. Whose conjugate base is being more stable, that acid is going to be more acidic, more stable. So this one is more acidic. This is being less acidic. You can say this acid is being like Tarjan. Tarjan can immediately give his jacket to any actress or like that. This is like Tarjan acid. Tarjan can immediately give his jacket to anyone, and he can survive without jacket. It can survive without jacket. Now kids, if you are able to understand, do let me know one thing. But before that, let me write down the relation that acidic strength of an acid acidic strength of an acid. Can I write like this, kids? Is directly proportional to minus I and inversely proportional to plus I. Kids, is it correct? Is it correct? Definitely minus I it is directly proportional, plus I it is inversely proportional. And one more thing, acidic strength of acid, acidic strength of an acid is directly proportional to stability of conjugate base. Stability of conjugate base. These 2 points you have to keep in your brain. These 2 points are really very important. Point number 1 and point number 2. These 2 points are definitely going to help you a lot because they holds a lot of bit of weightage for each and everything. One this point and one at this point. Now see kids, if you once you are able to understand all these things, how your work will become smoother. Now see kids, I'm going to frame out the question. Question is, arrange the following. Arrange the following in decreasing order of acidic strength, decreasing order of acidic strength. On this, I will give you total 5 questions. Agreed? I will give you total 5 questions and you have to answer all those 5 questions correctly. Kids, everyone ready? I will give you total 5 questions based on this. Is everyone agreed? Ready, kids? Do let me know. A, B, C, D. Let me think so that I can save your time. And A, B, C, D. A, B, C, D. First, second, third, fourth. A, B, C, D. D, C, B, A. B, A, C, D. C, A, B, D. And let me copy it. Let me copy it. 1, 2, 3, 4. Okay. Now see to it, everyone. See to it. Question number 1. NO2, CH2, COOH, then cyanide, CH2, COOH, then fluorine, CH2, COOH, then CH3, CH2, COOH. All of your answers are supposed to be correct. Then only I will say that you are able to understand. If all the answers are not correct, then I will say that you are not able to understand. Who has given the first answer? Muhammad Ahaya. Muhammad Ahaya first. Wow, that's really awesome. That's really awesome. This is your absolutely correct answer, kids. Absolutely. So it all depends on the power of minus I. So the key of these all three are having minus I, and this one is having plus I. So minus I being the friends. These are being the friends of this, and this is being the enemy. This is going to decrease the acidic strength. Now, one more thing, in questions they can also ask acidic strength is directly proportional to Ka value and inversely proportional to pKa values. So they can ask question like this also. Acidic strength is being directly proportional to Ka value and inversely proportional to pKa value. Now another question, see to it, everyone. Another question I'm going to give you, that CH3, CCl, CH2, COOH. Now CH3, CH, Cl, CH2, COOH. Now CH3, CH, fluorine, CH2, CH2, COOH. Now CH3, CH2, CH2, COOH. What's your answer, kids? What's your answer? I want to see your answer, kids. Everyone, do let me know first. Fantastic, really awesome. You are really genius, stupendous performance by you people. Really awesome, really awesome. Now see, here number is 2. Number is 2. Here 1, 2. You can say, or you can number from here 1, 2, 3. Third carbon, and 1, 2, 3, 4. Fourth distance. So in between these two, distance, and you can see this is the plus side, this is the enemy of it. So definitely that's why this is the answer. Now see kids, another question. Another question is, now what's your answer kids? Number of students are going for 3. So kids, let me tell you what's the answer over here. You can see 1, 2, 3. 2 NO2. 1, 2. Oh, this is on second carbon only. So B, first B, then A, B, A, C, D, B, A, C, D. What's the option? B, A, C, D. Third option is the correct answer, kids. Everyone, those who have got third as the answer, their answer is absolutely correct. Their answer is absolutely correct, kids. If you have got your answer as third, then third is the correct answer. Congratulations. Just show me the thumbs up. Yes, kids, you have done it. Done and dusted. Done and dusted. Really awesome, kids. Really awesome. Now, fantastic question. I'm going to give you fantastic question. See to it. Everyone see to it. HF, H2O, ammonia, CH4. Kids, this is super awesome question, and let me check it out. How many of you are going to give the correct answer, kids? This question is really awesome question, kids. Really awesome question, kids. Do let me know in the chat section what's your answer of this question. I want to see your answer, kids. Everyone, do let me know what's your answer. First, who is giving the answer? Number channel first. Yes, everyone, your answer is absolutely correct. See kids, everyone see to it. This fluorine's electronegativity is 4.0, oxygen is 3.5, nitrogen is 3, and carbon is 2.5. So do remember A, B, C, D. And let me tell you the key of this question. Let me tell you the key of this question, kids. Let me tell you the key of this question. This is really awesome question, and let me tell you the key. Key is whenever the size of atom, which atom? Then whenever the size of an atom, which atom? Atom bearing the negative charge. Atom bearing the negative charge. is same or approximately same. Kids, is same or approximately same. Approximately same. What I'm saying, whenever the size of an atom bearing negative charge is same or approximately same, then how will you come to know that size is same? Because you have never seen the atom. So I would like to say, when atom belongs to the same period, that is when atom present alone or the part of group present in the same period, which period? Long form of predictable. Present when atom present in the same period, present in same period. So when atom is lying in the same period, their size is going to be the same. Then stability is directly proportional, or stability is directly proportional to electronegativity. What does it mean? That negative charge is more stable on the most electronegative atom, but this is true only when the size gets, do remember, once again I'm telling you, this is true only when the size of an atom is same. When this size is same, kids, then only it is valid, otherwise it's not valid. So this whole story I can write like this, that negative charge is more stable on more electronegative atom, but do remember, this point is valid. What I'm saying, this point is valid only when the size of atom bearing the negative charge is same. When the size of an atom having the negative charge is same. Okay, kids, is this clear to all of you? Now, we are going to deal with some other questions on basic strength, next application. But before moving towards next application, I would like to give you one more question. See to it, kids. One more question I would like to give you. Okay, this slides though, let me delete. Not okay, let me make it. No, it's not working. Leave it. Next slide. Okay, now let's see to it. If the question is like this, kids, see, nitrogen A option, oxygen, nitrogen B option, C option is like this. Now these are the three options. What do you think out of these three options, which is going to be most? But this is not the acidic part. This is the basic part. So I would like to say this question I'm going to give you later on, because these are not acids, these are actually bases. So this basic strength I will deal with later on. Basic strength question, this is basic strength question, and let me tell you the answer also, because I haven't taught you. So I will explain it later on. This is going to be the most basic than this basic, because this is based on plus I. This is having electrons, both are providing plus I from both the side, plus I, this side also plus I, that side also plus I, but here one oxygen is acting as minus I, so it is decreasing the electron density, and here minus I is applied by 2 oxygen, so this nitrogen is having least electron density, It's by chance this question I have given over here, actually it is based on basic strength, so it is having maximum electron density, it is having maximum electron density. Kids, are you able to understand? So I'm going to tell you one more question based on acidic strength. This question is actually based on basic strength. By chance, because I was supposed to give you question based on acidic strength. One more question on acidic strength. See to it, everyone. So arrange, or you can say which one is having least, which one is having least pKa value, least pKa, kids, least pKa. Now see to it. CH3, CH2, NH2. B option is CH3, CH double bond NH. C option is CH3, C triple bond N. Once again basic strength, no. So once again basic strength. This is also based on basic strength. So let me rub it, because I'm giving you basic strength question and I was supposed to give you acidic strength question. Now see to it, kids. If I give you HF, HCl, HBr, and D option as HI. Now, which one is having least pKa value? This is your question. Kids. Do let me know. Everyone, do let me know, kids. Then I will give you, definitely I will give you break, because I've told you I will give you break at 9. I have told you after 3 minutes I'm going to give you break. Kids, after 3 minutes definitely I will give you break. A. Everyone is saying A. This is the thing, and this is the mistake most often made by most of the students. 99% students, they are going to make this mistake. Kids, answer is least pK means most acidic. Least pK means most acidic. And kids, its pK value is 3, its pK value is -7, it's -9, it's -10. This is going to be most acidic. Now kids, once it is going to be most acidic, now you will start saying, sir, now you will say, sir, you just taught us that negative charge is most stable on most electronegative atom. Then what happened to that? Kids, there was one condition applicable. I have told you that negative charge is most stable on most electronegative atom only if and only if the atom bearing the negative charge is having same size. Now there is size difference. See kids, fluorine belongs to second period, fluorine belongs to third period, bromine belongs to fourth period and iodine belongs to fifth period. Too much size difference. They are not of the same period. They are of, rather to say, they are of different periods but same group. The period is same but size difference. So do remember, kids, the most important point I am going to tell you. See to it. This is really very, very important. Negative charge is most stable on the biggest atom, on the biggest atom. This is the point number one, which always keep in your brain. The most important point in this world, that do remember that negative charge is most stable on biggest atom. That's why at that time I was focusing more and more on that point, that when the size of atom bearing the negative charge is same, then only negative charge is most stable on most electronegative atom. Otherwise, kids, this is the fundamental thing. Negative charge is most stable on the biggest atom, and that's why we used to say I negative, because the size of I is very much. This is being I can say the size of iodine is too much. What happened to the size? Where it's gone? Kids, this is I negative, this is Br negative, this is Cl negative, and this is F negative. See the size difference, kids. Just see to it. If I draw the size of iodide, this much is iodide. See, size of iodide is too much. Bromide is less. Chloride is even less. And see, fluoride is very, very less. So size matters a lot. Iodide size is too much. This is being iodide, this is being bromide, this is being chloride, and this is being fluoride. So this is the biggest in size, kids, biggest in size, and the most stable. The stability order is like this. So first point is always see the size. If size is different, then this is the acidic strength order. And kids, this is really going to help you a lot in inorganic chemistry also. See to it. If I talk about inorganic chemistry, I'm going to give you a break. Don't worry, kids. Don't worry. So if I talk about inorganic chemistry, how you are going to solve the question. See, CH4, ammonia, H2O, HF, and if I talk about HF, then HCl, then HBr, then HI. So kids, see to it how the acidic strength order deals and how it works. See to it, everyone. The acidic strength is moving like this and the acidic strength is going like this. So see here, the size of atom bearing the negative charge is same. The size of atoms bearing the negative charge is same or approximately same. All these four, their size of atom size, because they all belongs to second period. They all are placed in second period. So the size is approximately same. Size of atom is approximately same, kids. So the acidic strength order is like this. This is more acidic, this is more acidic, this is more acidic, this is being more acidic, this is being more acidic, and this is being more acidic. This is the theoretical aspect. If I talk about experimental aspect, so its pK value, if I talk about pK that is being experimental, it is somewhat 50, it is somewhat 35, it is somewhat 15.5 at 25 degree Celsius. This is somewhat 3, this is -7, this is minus 9, and this is 10. If you go to the inorganic chemistry, then question number of times it has been asked, H2O, H2S, oxygen, sulfur, selenium, tellurium. So the acidic strength increases like this. Acidic strength. If I talk about nitrogen, ammonia, phosphine, arsenic, antimony, bismuth, the acidic strength increases like this. The acidic strength moves like this because the size of atom bearing the negative charge increases, and the size of atom bearing the negative charge increases. So the acidic strength increases. Acidic strength increases. You must have studied in P block that phosphine is more acidic than ammonia, and H2S, hydrogen sulfide, is being more acidic than water, kids. So after this, I will let you know basic strength, and then I will let you know hyperconjugation, and after hyperconjugation we will try to proceed towards resonance. So I'm going to give you break, but break of 15 minutes, okay kids? 1 5 15 or 20. So what time of break, what slot? 15 to 20 minutes, 15 minutes or 20 minutes? How many minutes break you require? But 20 minutes. But make a promise, kids. Make a promise. I'm going to give you 15 minutes break, 1 5. But do promise that you are not going to eat too much, so that you will start feeling sleepy and you are not going to come back. Please. 20 minutes. Okay, everyone is asking 20 minutes. But everyone, make a true promise that you are not going to eat too much, so that you are going to get sleepy, feeling sleepy, and you are, once you are going to bed, definitely you are going to lie down over there and you will, definitely you are going to sleep. Kids, promise? Gentleman promise? Gentle student promise? Okay, so right now what's the time? Right now the time is, right now the time is 9:07. At 20 to 9:07, break. Break. Yeah, good, good. So break is from up to 9:25. Up to 9:25. Okay, fine kids. Up to 9:25. We will meet at 9:25. We are going, definitely we are going to meet at 9:25. Okay kids, fine? Is it fine? Let me write down 9:25. Welcome back, kids, once again to your Unacademy NEET English channel. I'm here and I hope that everyone must have gone through some water, some snacks, fruits, so it acidic, not good at this time. But yes, you must have eaten a little bit to get energy so that you should feel more energetic. So, kids, let me know in the chat section that yes, everyone is back with full on josh, having full on energy, highly energetic. Yes, kids. Resonance, yeah, definitely. Today, my aim is to reach up to aromaticity. Today, resonance complete. Resonance, we won't be able to complete it, but yes, my aim is, my target is to reach up to aromaticity. I would like to reach up to aromaticity. So, kids, don't ask for the time, okay? It's definitely, this is a time when we can study a lot, because these all topics, they are going to the most important, and these really, they hold a hell lot of weightage. But again and again, I'm telling you, kids, these are really very important. So everyone is here, just show me your attendance, smash the like buttons, hit the like buttons. I want to see your attendance. Once you back, hit the like buttons. I want to see the like buttons. The number should get increase, and that should reach up to 500. I want to see the number increasing. If your energy level is best, then definitely the like buttons, they should get moving up and up. Okay, kids. So I can see the josh and the energy. Let's start the application number 5. Kids, let's go with the application number 5. I hope that everyone is back with full on energy. See, application number 5. We are going to deal with application number 5. That is the basic strength. Application number 5, that is being the basic strength. And definitely basic strength. What is the basic strength? The first point is that what actually the basic strength means. Basic strength means basic strength of amines. That how easily the nitrogen can donate its lone pair. How easily nitrogen can donate its lone pair. Now, kids, who is going to accept that electron? Who is going to accept those electrons? Because nitrogen is donating lone pair, so somebody must be gaining it. So it is donating its lone pair to proton. So we can also say, in other words, see, kids, like we are dealing with ammonia. and there is water. Now, this ammonia is saying, hey, I'm having lone pair, I'm having money, electron money. H2 is saying, oh, I have got one proton. Please give something to this proton because this is without electron. This is just having proton. Proton, hydrogen. Hydrogen, if we talk about hydrogen, hydrogen is having one electron and one proton, zero neutron. So its electron has been lost. Now hydrogen is remaining only with proton. That's why it is known as protium. Now this is proton donor, H plus donor. So people will say you are an acid. And this is proton acceptor. Proton acceptor, I can use the word, or I can use another word, that lone pair donor. Lone pair donor. This is lone pair donor or proton acceptor. So definitely it's all depends on us how we are saying. So it will become ammonium NH4 positive, and that will become OH negative, and people used to say ammonium hydroxide NH4 OH. So this is acid base neutralization. Here ammonia has played the role of base, and this is acting as acid, ABN, acid base neutralization. Now kids, one very important question arises, whether they are donating their lone pair in air or in water. Because if you talk about air, that is being gaseous state, and if you talk about aqueous state, that means a lot, because a lot of difference is being there. So let's talk about that, the basic strength in both the two mediums. Now see kids, if I talk about basic strength in gaseous state, if I talk about basic strength in gaseous state, basic strength is just directly proportional to plus I. Just this much only we have to see. We have to talk about this much only. If I talk about strength, basic strength is just dependent on plus I, nothing else, only one factor kids. But do remember what they are asking. If they are asking about gaseous state, that means I would like to say that 3 degree amine will be most basic. Now number of times kids they are asking that whether the state will be mentioned or not. Yes, if they are asking for gaseous state, they have to clearly write down over there that we are talking about gaseous state. So we would like to say, and particularly over here I would like to say this is 3 degree amine, because nitrogen is attached with 3 carbons. So 3 degree amine, then 2 degree amine, then 1 degree amine, and this is just the ammonia. So this is the basic strength order. But I would like to say once again, categorically I would like to say that if gaseous state has been mentioned, then only you are going to answer this. If mentioned not, what? If state is not mentioned, then what will you do? So whenever the state is not mentioned, then which state you are going to take kids? Do let me know. Do remember, whenever state has not been mentioned, what will you do? Always take it to be aqueous. Always take it to be aqueous. Now kids, once you are taking aqueous, experimental data, you have to learn about experimental data. You need to know experimental data. What's that? Experimental data. Just cram it. Cramming is required over here, that 2 degree, then 1 degree, then 3 degree, then ammonia. But this part is valid when R is methyl. When R is methyl. When R is methyl, you have to follow this data, kids. Just keep it in your brain that you have to follow this data when R is methyl. But when R is ethyl, what you are supposed to do? When R is ethyl, then remember 2 degree, then 3 degree, then 1 degree, then ammonia. This part is when R is ethyl. Now kids, to understand anything, that is being more easy as comparison to learning or cramming. Now kids, this data has been given in NCERT. This data is already given in NCERT, and number of times it has been asked. But how to learn it, how to cram it, see to it, everyone. See to it, everyone, that what I'm talking about, this 2 degree common, it's given over here also 2 degree and last ammonia, and over here also 2 degree last ammonia. Where is the difference? The difference is only in this 3 degree then 1 degree, and here 1 degree then 3 degree. Kids, see, I'm going to give you one awesome trick. Methyl is smaller number, smaller, and ethyl is bigger. Ethyl is bigger. So just see, for a smaller methyl, smaller number, smaller, and bigger, this number is bigger. Everyone is able to understand? Do you like this trick? If yes, do let me know. Kids, have you liked it? For bigger number, for smaller number. It's all about this, and this is really awesome. Everyone got it? Are you able to understand? Do let me know, kids. Hey kids, I can see you from here. Everyone, do let me know in the chat section that if you're getting it or not. Everyone. Very good. That's really fantastic. Now, so this is all about now how this data has come. What are the factors which are responsible for this data? Let me tell you what are those factors. See to it, kids. Factors responsible for this data. Three main factors responsible for this data. First factor is being inductive effect. Inductive effect says my vote is for 3 degree, because 3 degrees with maximum electron density, so 3 degree should be most basic. This data and this voting is given by inductive effect. Now second vote is of steric factor. You know steric factor? Steric factor talks just opposite to it. Steric factor says my vote is maximum for 1 degree, then 2 degree, then 3 degree, and then my vote is maximum for ammonia. My vote is maximum for ammonia, then for 1 degree, then for 2 degree, then for 3 degree. People starting saying, oh, you're just talking opposite to inductive effect. What is this? Why are you talking like this? This steric factor said, you see, it's very easy to attack on the lone pair of nitrogen, because these hydrogens are very small. They are not creating any hindrance. These are very small, very small hydrogens. They are not putting any steric hindrance. You know steric hindrance, when you are moving on the highway. On highway, there is no steric hindrance of any car, truck like that. Too much space is over there. So car and trucks, they are lying, and they are just moving far away from each other. So you can get the speed. So this proton is saying it's easy to attack over here. No steric hindrance, no problem is there. But if we talk about nitrogen, then carbon, hydrogen, 3-degree amine. So it's like this somewhat. It will look like this. And these atoms are occupying too much space. So I find very difficult to attack on this lone pair. So this lone pair is too much sterically hindered. Are you able to get it? These are atoms, and this lone pair is just surrounded by all these atoms. So very tough. I find very tough to attack on this lone pair. Everyone is able to get it. So maximum vote for this. Now the third factor. The third factor is hydration energy. Let's see, hydration energy's vote is going to. Hydration energy says, kids, He is hydration energy. Hydration energy. What is hydration energy? When water is going to form maximum bond with particular thing, so whenever the molecules are coming closer, definitely they are going to release energy. This is doing exothermic reaction. You know, energy is required to break the bond, and once the bond is getting formed, energy gets released, and this energy is hydration energy. So it is saying my vote is maximum for ammonia. I'm going to vote for ammonia, then 1-degree amine, then 2-degree amine, then 3-degree amine. People asked why is like this. So hydration energy is saying, see, ammonia is like this, water is like this, and ammonia is acting like base, and water is acting like acid, and acid base neutralization is being taking place, and what you are going to get, NH4 plus and OH negative. Now 4 hydrogens, nitrogen is having 4 hydrogens. Now see, this is nitrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen, positive charge. So this ammonium ion, this is being ammonium, this is being ammonium, this ammonium ion will be surrounded by 4 water molecules. It is going to form 4 hydrogen bonding. 4 hydrogen means 4 hydrogen bonding. So maximum energy is going to get released over here. Maximum energy is going to get released. Ammonia is going to form 4 hydrogen bonding. So maximum energy, maximum hydration energy, maximum energy will get eliminated out. So it is going to release maximum energy, and this is going to give least hydration energy, least hydration energy, least hydration energy. So if examiner is asking that what are those factors which are responsible for disorder, so these are the factors. I hope clear to all of you. Now this is completed. Now we are going to move towards hyperconjugation. In the starting only I have told you RHIS, RHIS, resonance, hyperconjugation, inductive effect, electronegativity. Electronegativity has been completed, inductive effect has been completed. So whatever the examples I have provided you, examiner is definitely going to ask from there only. So kids, I'm telling you each and everything from the scratch. I'm not going to skip even a single word, kids. The kids, those who are studying in Avengers batch, and the kids, those who are studying over here, there's no partiality. I'm not going to make even a single word to get skipped, kids. So each and every kid is definitely valuable for me. So everyone ready? Are you ready for hyperconjugation? Everyone just do let me know. Everyone say, do let me know that are you ready for hyperconjugation? Hyperconjugation, are you ready? So hyperconjugation, it's really very important. Hyperconjugation. So do you know another name for hyperconjugation? Do you know any other name for hyperconjugation? Hyperconjugation is also known as kids. Do let me know. Hyperconjugation is also known as no bond resonance. No bond resonance. Keep in your brain. Resonance, no bond resonance. This is also known as sigma pi conjugation. Sigma pi conjugation. This is a question of number of examinations. Sigma pi conjugation. This is also known as sigma bond resonance. Sigma bond resonance. Sigma bond resonance. This is also known as Baker-Nathan effect. Kids, Baker and Nathan effect. Baker and Nathan effect. These are the names given for hyperconjugation. This is one of the most important question of number of examinations, that what are the other names for hyperconjugation. So these are the total names, 1, 2, 3, 4, 5. 5 names for hyperconjugation, and this is really going to hold a hell lot of weightage, kids. Now let's see what kid is asking. Mangunthru's no bond resonance. Yes, no bond, non-bonding, it's no bond resonance. Now let's see what is hyperconjugation actually. Kids, hyperconjugation, how it works and what is actually meaning of hyperconjugation. See to it. So in 3 type of compounds we are going to study hyperconjugation. 1, 2, 3. Any idea about what are these 3 compounds where we are going to study hyperconjugation? First is being an alkene. We are going to study hyperconjugation in alkene. Second is being carbocation. And third is being free radical. These are the 3 areas where hyperconjugation works, and we are going to deal stability of all 3. Stability order of all 3. So are you ready, everyone? I hope everyone is ready. So we are going to start with alkene. So first point is alkene, and see how it is going to affect alkene and what is going to happen in alkene. Everyone see to it. An alkene. We always used to say alkene's stability. We use this word. Alkene's stability is directly proportional to number of alpha hydrogen atoms. This so you must have studied number of times. Now kids, today we are going to focus on that why number of alpha hydrogens are necessary and what is there that they are going to increase the stability of alkene. What's that? So see how it works. So you must have seen propene, CH3, CH double bond, CH2. Before I start dealing with propene, let me tell you some examples. If I talk about this alkane, then carbon to carbon bond length is 1.54 angstrom. Do remember this bond length because examiner will definitely ask this bond length. And without knowing this definition, without knowing this bond length, we won't be able to do anything. And if I talk about carbon-carbon double bond, then this is just 1.34 angstrom. What is the bond length of single bond carbon to carbon, kids? Carbon to carbon single bond length is 1.54, and carbon to carbon double bond is 1.34 angstrom. Just keep it in your brain that this is lengthy, this is short, this is lengthy, this is short, this is more, this is less. One is being more, one is being less. So if anyone is asking what is this bond length, if anyone is asking what is the bond length X and what is Y, what is X and what is Y, could you please answer me? Would you like to answer me? Would you like to answer me what is the bond length of X and what is Y? So answer is X is less than 1.54 angstrom. How much we don't know, but yes, it is less than, and this is being, Y is being more than 1.34 angstrom. This has been practically observed. Now kids, question arises, why the single bond's bond length got decreased and why the double bond's bond length has been increased? What is responsible thing? Who is responsible for that? Now kids, this is really interesting. This is really going to be interesting. We have seen propene like this. But kids, the one who is intelligent will never see propene like this. The one who is intelligent would like to see propene like this. Intelligent people will see propene like this. Now kids, the one who is more intelligent than this intelligent will not see propene like this. The more intelligent one is going to see propene like this. Delta negative, delta positive, delta positive, delta negative, delta positive, delta negative. Now, see kids, this is the first one, this is the second one, this is the third one, and the third one is being more intelligent, so he would like to see, or she would like to see propene like this. See, carbon negative, hydrogen CH double bond CH2, because this guy is really intelligent. Now he has seen that sigma bond, the one which we were saying sigma bond, the one which we said broken sigma bond. Now sigma, this broken sigma bond has converted into pi bond. This broken sigma bond got converted into pi electron. Now once it has converted into pi electron, it will start doing resonant, it will start doing movement from this to this. Now it is moving. Now you can clearly see this has developed double bond, and double bond has converted to single bond. My dear students, see how it got changed, how it is growing, Somebody has seen it like A, somebody has seen like B, somebody has seen like C, and somebody has seen like D, and somebody has seen like E. None of them is correct structure. See, from here to here is resonance, in between these two is resonance. So what is actual structure of propene? Kids, are you getting? It's really interesting. Without having the idea of all these structures, you are not going to study, you are not going to understand anything. Now see, these two structures, they are going to give you an idea about it, what actually propene is. So see to it. The propene which you have always seen like this, actually the propene is like this. See to it. This is your propene, kids. CH2, CH2. Now proton is always in moving condition. This carbon is having delta negative, this carbon is having delta negative, and the electrons are moving like this, Sometimes the hydrogen is present at this carbon, it is forming the bond, and sometimes the same hydrogen on this carbon moving the bond. So it's not single bond, that is also not a single bond. The single bond has developed some partial double bond character, and double bond has developed some partial single bond character. There's no pure, no single bond. This was the single bond developed partial double bond character and double bond has developed some partial single bond character. Now, due to this, pi bond has shifted. Pi bond has acquired some single bond character, and no one is going to attack on pi electron easily. Once the pi bond has not going to be attacked by someone easily, so this is the thing which is responsible for increasing the stability of alkene. And whatever the number of sigma bonds, which sigma bond, let me tell you kids, let me tell you kids, first of all, let me tell you in short, the students who are not able to understand in detail, let me tell you in short. If you see these hydrogens, these are hydrogens directly attached to double bonded carbon. Double bonded carbon is known as sp2 hybridized carbon, or this is also known as olefinic carbon. Now, hydrogen atoms directly attached to sp2 hybridized carbon, they are known as, very important term is there, they are known as vinylic atoms, vinylic hydrogen atoms. Now kids, this carbon, people used to say this is being alpha carbon. You must have heard this name, alpha carbon, and these three are being alpha hydrogens. These are three. There are three, total in all, three alpha hydrogen atoms. These are known as allylic atom. Scientists used to say these are being allylic atoms. Allylic hydrogen atoms are loosely bonded. These atoms are loosely and they are being strongly bonded. These olefinic hydrogen atoms are being strongly bonded. These are strongly bonded. These are being strongly bonded. And these are being loosely bonded. Once they are being loosely bonded, so they can eliminate out easily. So these are good leaving groups. They are being poor leaving groups. Vinylic atoms are poor leaving group. They are not going to leave, poor leaving groups, poor leaving atoms or groups. And allylic are always good leaving groups or atoms, good leaving atoms. Now kids, this is the $1 million thing, that if somebody is asking that compound has been provided like this, see to it. If the compound has been provided like this, CH3, CH2, CH, double bond, CH2, and they have given the bond lengths like this. Suppose they are saying this is being X, this is being Y, and this is being Z, and arrange all three bond lengths in the decreasing order of bond length? This is $1,000,000 question. What's the question? What is the question? Question is, arrange these three, arrange X, Y, and Z in decreasing order of bond length. Decreasing order of bond length. Now see kids, this is your olefinic carbon and this is alpha carbon, and these two are being alpha hydrogens. So that means this single bond will develop partial double bond character, and the single bond will develop partial double bond character, and this double bond will develop partial single bond character. Now kids, if any bond is pure single bond, then its bond length will be 1.54 angstrom exactly. Now because this single bond has developed partial double bond character, so this bond length should be slightly less than 1.54. Let us suppose 1.53, I don't know how much, but less than 1.54. And if there is pure double bond, its bond length is supposed to be 1.34 angstrom, but this has developed partial single bond character, so it should be slightly more than 1.34. let's suppose 1.36, 1.37, I don't know. So you see, X, then Y, then Z. Everyone is able to understand? If yes, then do let me know in the chat section kids. If this question is really awesome question, if everyone is able to understand, do let me know that yes, you got it. Everyone, do let me know if you are able to understand it. Really, this was awesome question. Now see kids, I'm going to give you one question. If you are able to understand, do let me know what's the answer of this question kids. CH2 double bond CH, C, CH3, CH3, CH2, CH double bond CH2. Okay, so they have given you this to be the X, this to be the Y, this to be the Z, and this to be the M. Question is same. Arrange all these four bond lengths in decreasing order of bond length. Arrange in decreasing order of bond length. Kids, do let me know what's your answer. Arrange X, Y, Z, and M in decreasing order of bond length. Bond length. Now see kids, this is the double bond and this is alpha carbon but no hydrogen. See, on this carbon sp3 hybridized adjacent to olefinic carbon being sp2 hybridized, there is no hydrogen. On this carbon there is no alpha hydrogen. No alpha hydrogen. So no hyperconjugation. No hyperconjugation. And once there is no hyperconjugation, so this is pure double bond. Pure double bond. And once it is being pure double bond kids, the bond length is going to be 1.34 angstrom. And this one is pure single bond. Once it is being pure single bond, bond length is 1.54 angstrom. But this double bond, you can see this is sp3 hybridized and it is having two alpha hydrogen atoms, and two alpha hydrogen atoms means hyperconjugation will take place. There will be hyperconjugation, and once there is hyperconjugation, that means the single bond will develop partial double bond character, so the bond length will decrease. I don't know how much, but yes, it will decrease, and it will get increase. I don't know how much, but yes, 1.35, 1.36, I don't know how much, but it will increase. So the answer you must have got. So this is being the most maximum bond length. That means maximum bond length is of Y. After Y there is Z. After Z there is M, and after M there is X. If you got this answer, do let me know in the chat section that yes sir, we have got this answer. How many of you have got this answer? Do let me know in the chat section, kids, that this is your answer. I want to see your answer, kids. Is your answer like this? If yes, then it's really fantastic. Hey kids, where you have lost, do let me know in the chat section. I want to see your answer. Hey, fast, fast. I want to see your answer, kids. What are you waiting for? What are you waiting for, kids? Do let me know. Have you got this answer? Because your success is waiting somewhere. Don't get tired, because if you're working hard, your success is waiting somewhere. Everyone make a wish like that, I should get the best rank. But kids, do for it. Now kids, let me tell you, for rank deciding question, for rank deciding, for top 100 rank, this is for top 100 rank. What happens during hyperconjugation, that is being molecular orbital theory approach. Molecular orbital theory approach. Now let's see this approach. What this approach says, that we are having this sigma bond and we are having this pi bond, where actually the electron is getting transferred, because I said this hydrogen is breaking. Actually this sigma bond, this is being sigma bonded electron, and this is pi bond. So who is vacant? Pi bond is of low energy, so pi anti-bonding is also of low energy. This is being pi anti-bonding, this is being pi bond, and this is, there is pi anti-bonding, pi star, pi star. So sigma bonded electron is moving to pi anti-bonding. So there is transfer of sigma bonded electron to pi anti-bonding, that is star, pi anti-bonding molecular orbital, sigma bonding molecular orbital, so pi anti-bonding. This is the molecular orbital theory approach, and this question has been asked in AIMS, right? Now see kids, simple question or the applications of hyperconjugation we are going to deal with. Applications of hyperconjugation, see to it kids. Applications of hyperconjugation. All the applications I am going to let you know, because I have told you I am not going to skip even a single word. So application number one, stability of alkene. Stability of alkene is directly proportional to number of alpha hydrogen atoms. So how the question will come? Question will come like, question number one, CH3, CH double bond CH, CH2, CH2, 1, 2, 3, 4, 5, 6. One compound. This is, let us suppose A, B, CH3, CH2, CH double bond CH, CH2, 1, 2, 3, 4, 5, 6. Now let us suppose this is C, CH3, CH3, C double bond C, CH3, CH3. They all are having 6 carbon atoms. I can say they all are C6H12. They all are being C6H12. Now out of these three, which is being most stable? The question is most stable and least stable. Most stable and least stable. I want to see in the chat section. I want to see in the chat section that whether you are able to answer it. CAB, yes. Who has given this answer? Muhammad Ahiya, fantastic. Claps for you. Really, kids, if you are able to answer all the questions over here, that means you are moving on the right track. Now see to it. This is olefinic carbon and this is alpha carbon, alpha carbon, alpha carbon, alpha carbon. 3, 3, 3, 3. 3 plus 3 plus 3 plus 3. 12 alpha hydrogen atoms. 12 alpha hydrogen atoms. More the number of alpha hydrogens, more will be the hyperconjugating structures. More hyperconjugative structures. More hyperconjugative structures. And more will be the stability. Now see, if I talk about this is being olefinic carbon 2 plus 2. 2 plus 2, that is just 4 alpha hydrogen atoms. Now in this is olefinic carbon 3 and 2, 5. Oh, this is having 5 alpha hydrogen atoms. 3 and 2, 5 alpha hydrogen atoms. This is being more stable. See kids, it was having just 2 and 2, 4. 2 and 2, 4. So 12, 4, 5. So definitely C, A, B. Muhammad has given the correct answer. And this is really the correct answer. Stability order. Can you see everyone? This is being stability order. Is it clear to all of you? Kids, more the number of alpha hydrogen atoms, more is going to be the stability. Kids, everyone hit the like buttons. I want to see likes to get increase. Everyone, kids, I want to see the number of likes should get increased. If you're active, do let me know. Don't ask Prajwal Prajapatji when the lecture is going to get over, because right now important thing is that we should know at least hyperconjugation. If we don't know about even hyperconjugation, we can't do anything in GOC. So kids, everyone see to it. Application number 2. Let's move towards application number 2. Now see to it, everyone. Application number 2. Stability of carbocation. Stability of carbocation. Stability of carbocation is directly proportional to number of alpha hydrogen atoms. This is also directly proportional to number of alpha hydrogen. Just like stability of alkene was directly proportional to number of alpha hydrogen. Kids, everyone, are you able to listen? Are you awake, full on energy? So this also directly proportional to number of alpha hydrogen atoms. So see to it, kids. If I am going to write this tertiary butyl carbocation, which already we have seen during the inductive effect. Now kids, how many alpha hydrogen? How you are going to judge for alpha hydrogen? See, this is carbon positively charged. Whatever the number of carbons directly attached with this carbon, all are they being alpha carbon, and the hydrogen attached with alpha carbon is being alpha hydrogen. So kids, how many alpha hydrogens we are having? How many alpha hydrogens we are really having? Kids, do let me know. We are having 3 alpha hydrogen atoms, 3 alpha hydrogen atoms, and 3 alpha hydrogen atoms. So total 9 alpha hydrogen atoms. Now kids, once the question has been asked that how many hyperconjugative structures it will be having, number of coachings they have given the answer 9. No kids, 1 plus, because 1 this structure. If I am having 9 brothers, then I am also 1. So 9 plus 1, 10. So 9 plus 1, 9 plus 1, total 10 hyperconjugative structures. Total 10 hyperconjugative structures. Now kids, this is being the most stable. If anyone is going to ask that this is having how many alpha hydrogen atoms, do let me know kids. CH3, CH plus, CH3, isopropyl. This is being isopropyl. How many alpha hydrogens? If you are able to understand, if you are able to understand number of alpha hydrogens, if you are able to count number of alpha hydrogen atoms, do let me know. 6. Very good. 6. See to it, everyone. That's really fantastic answer. 3 over here and 3 over here. 6 alpha hydrogen atoms. So this is on second number. This was having 9 alpha hydrogen atoms. This is having 6 alpha hydrogen atoms. So if anyone is asking, this is having how many alpha hydrogen atoms? So this is having 3 alpha hydrogen atoms. So this is the stability order. This is being 3 degree because it is attached with 3 carbons. This is being 2 degree and this is being 1 degree. Kids, are you able to understand? This was the second application of hyperconjugation. Now if we move towards molecular orbital theory, kids, molecular orbital theory. Now see, it's molecular orbital theory of carbocation. Let's see the molecular orbital theory approach, MOT approach. What happens over here? MOT approach says that this is being carbocation. This is suppose R1, this is suppose R2, and there is carbon and hydrogen. What happens? Now see, this carbon is being positively charged. That means it is having pure p orbital. This is being your pure p orbital. Pure p orbital. Now this is being sigma bond. Now this sigma bonded electron will shift to pure p orbital. This is the answer. Once it has been asked in AIMS that what happens. So sigma bonded electron moves to pure p unhybridized vacant orbital. Now kids, this is the application number 2nd. Now let's move towards application number 3. Kids, how's the Josh? I think once it is, the time is, right now the time is 22:19. Just 10:20. 20 past or 19 past 10. You must be feeling sleepy. How many of you are feeling sleepy? If you're not feeling sleepy, then show your hands, raise your hands, thumbs up, some fire in the chat section, kids. You are going to become India's, not only India's, world's, not only world's, universe best doctor. And to become, if you want to become best doctor, you can't feel sleepy right now, kids. You see how much hardworking your teachers are on this platform. How could you think about that? I'm feeling sleepy, kids. No. If you're feeling sleepy, just have some water. You can have some water. Just take water like this and start drinking. See, I have to brought full on of this, right? This mud pot full with water. Kids, whenever you are feeling sleepy, just take some water, H2O, liquid H2O as gift and have it. Tasty water, tasty water, tasty water, really tasty. Now see kids, application number 3. Application number 3. See to it, application number 3. Third application, stability of free radical. Stability of free radical. This is also being directly proportional to number of alpha hydrogen atom. All the three are directly proportional to number of alpha hydrogen atoms. Now kids, how to find out number of alpha hydrogen atoms? See to it, everyone. If I write this is the free radical, R1 some valency over here, R2 some valency at this place, and this is carbon attached with even with single hydrogen. Just the carbon which is directly attached to this carbon, the one is free radical carbon. This carbon is your alpha carbon, and the hydrogen attached to it is being alpha hydrogen atom. This is being your alpha hydrogen atom. So kids, are you able to understand what is alpha hydrogen atom? If yes, then do let me know. This is carbon R1, R2, and carbon, this is, let me write down, okay. In this way, you won't be able to find out how many alpha hydrogen. Let me draw the compound. C, free radical, CH3, CH3, CH3. Kids, do let me know. This compound is tertiary butyl free radical. Tertiary butyl free radical. This is having how many alpha hydrogen? How many alpha hydrogen? Kids, do let me know how many alpha hydrogens are there. 3, 3, and 3. So 3 plus 3 plus 3, that is 9 alpha hydrogen atoms. So this tertiary butyl is highly stable. Now let's compare. Let's compare, kids. If I draw this compound, see, if I draw this free radical, this we have seen in the free inductive effect application also, and with the help of inductive effect we have explained the answer. Now it's turn to explain it with the help of hyperconjugation. Hyperconjugation is better than inductive effect. Why it is better than inductive effect, I will let you know when I'm going to let you know the valence bond theory of it. Just to let me know, kids, just to let me know, this compound is having how many alpha hydrogen atoms? 9 alpha hydrogen atoms. But this compound is having, see, this is free radical, this carbon, 6 alpha hydrogen atoms. This is free radical, these are not alpha hydrogen, this carbon is attached, 3 alpha hydrogen atoms. So it is having 0 alpha hydrogen atom, 0 alpha hydrogen atom. Kids, can you see? This is 3 degree free radical. 3 degree free radical is more stable than 2 degree free radical is more stable than 1 degree, and so this is not having any alpha hydrogen atom. So this is the stability order, kids. Could you please let me know in the chat section whether you are able to understand it or not? If yes, show me the thumbs up, kids. If yes, just show me the thumbs up. Everyone is able to understand, kids. Everyone do let me know. Now see, kids, molecular orbital theory approach. It's MOT approach. Molecular orbital theory approach. MOT approach. Now see, kids, what is the MOT approach? It says that this is being free radical. R1 valency is there, R2 valency is there, and now let us suppose this is hydrogen. Now you can see I have told you this is pure p orbital, but this pure p orbital is not empty, it is having one electron. In carbocation this was not having electron, but this orbital is having one electron. So this sigma bonded electron will shift to this partial filled. So sigma bonded electron will shift to partially filled SOMO. This is known as SOMO. SOMO is singly occupied molecular orbital. What is SOMO? It's not Tata Sumo. It's not the wrestling sumo. It's SOMO, singly occupied molecular orbital. This question also have been asked in IIT as well as AIIMS. SOMO stands for singly occupied molecular orbital. Now kids, these three applications we have seen about the hyperconjugation. Now there are more applications of hyperconjugation. There are number of applications, but the heat of hydrogenation, the heat of combustion, the orientation effect, reverse hyperconjugation. So I will let you know each and everything. I'm not going to skip even a single thing. People must be waiting. That's when you are going to tell us about resonance. Kids, before starting anything, we should know each and everything, whatever the topic is going on. Agreed or not? Yes, you must be agreed. Now, application number 4. Orientation effect. What is orientation effect? See to it. It's A part, ortho and para directing effect. Now see to it, kids. If I talk about benzene, if this benzene is attached with any carbon having at least one hydrogen, this hydrogen is known as benzylic hydrogen. Kids, what? See, in case of benzene, these are known as vinylic hydrogen. No, arylic, because this is being aromatic. Benzene is being aromatic. This is the resonating structure of benzene, and this compound is being aromatic. And once this compound is aromatic, the vinylic one over here is known as arylic atom. It is given in a class 12th. Arylic atom. And this sp3 hybridized carbon, and this hydrogen is known as benzylic hydrogen, just like allylic. This is benzylic hydrogen atom. And I would like to say only one thing, why we have to consider it like this. Even we can see it simply. In simple language, we have just to see alpha hydrogen. More the deeper we are going, more you will get confused. So let me tell you straightforward that this is your benzene, resonating structure of benzene. And if you are having even a single hydrogen at this position, this hydrogen is known as alpha hydrogen, because this carbon is alpha carbon. So this carbon is having this property, and this is alpha hydrogen atom. This alpha hydrogen is, I've told you, is broken hydrogen. This is being delta positive, this is being delta negative. And if you're seen up to this much, you can see much more. Now see to it, kids. This is your resonating structure of benzene. It look like this. And this carbon is having negative charge, and once it is holding negative charge, this electron will do resonance, and this electron will say, oh, I want to come over here. This electron has to go over here. Once it has gone like this, kids, it will start moving, and it will not get stopped. It will become unstoppable. And now this electron will once again say, I want to move. I want to move. Okay, who can stop you? You have become unstoppable, and this will come over here. Now what you will see, kids, you will see something like this. It's going to happen. See, now electron is saying, I want to move, I gotta go, I want to go. Okay, you go. You will come over here, it will come over here. Once it will come over here, you will get compound like this. Now this electron will say, oh, I want to move, I want to move. Okay, you come over here, it has to go like here, go. So electron is doing resonance. Electron is moving from east to west, north to south. Now it has come over here and it has over here. Now electron is saying, oh dear, I want to go back. I want to go back to home. Okay, if you want to go back to home, just go. Who is going to stop you? From wherever you have come, just go at this place. So these 5 resonating structures. See kids, number of resonating structures, and while moving these electrons, the negative charge has developed where? At ortho, at para, and at ortho. Ortho, para, ortho. So whenever some electron deficient compound is going to attack on this benzene, it will attack on the ortho and para position, and that's why this compound is known as ortho and para directing group. This is known as ortho para directing group. Ortho para directing. So none of the structure is being the clear structure. If you want to draw, you can draw resonance hybrid of it, and how it will look like. The resonance hybrid will look like this. Delta negative. Delta means partial negative. The electron has gone like this, and the carbon also developed delta negative, and this has also. This is the true structure, and this we will say the resonance hybrid. Resonance hybrid. So this is known as hyperconjugation, and even we can say plus H for hyperconjugation. Now kids, next application is really very important, reverse hyperconjugations. Let's see to it. What is reverse hyperconjugation? See, reverse hyperconjugation, that is application number 5. We are going to deal with application number 5. This is really very important. Number of times this question has been asked, kids. Now I'm going to tell you, this is really very important. See to it what I'm going to tell you. Reverse hyperconjugation. This is the application number 5. Reverse hyperconjugation. Reverse hyperconjugation. It is also known as -H. Now where it is going to take place? See kids, if the compound is like this, carbon attached with 3 halogens, let us suppose chlorine. Now kids, whatever the atom is placed on this benzylic carbon, that is good leaving group. So once again, earlier they were hydrogens, now they are chlorine. They are very good leaving group, very good leaving group. Lg stands for leaving group. Now kids, they are being more electronegative than this carbon, because the carbon's electronegativity is just 2.5. This carbon's electronegativity is just 2.5, and their electronegativity was 3.19, being more electronegative. So they will take electron of carbon, and once the electron has been lost, how it will look like? This carbon will develop positive charge. Once this carbon has developed positive charge, now this carbon will say to benzene, hey benzene, give me your electron. I want to take your electron. I want to have your electron. So this will shift over here. Once it is losing, it will develop positive charge. It will develop negative positive bond. Now see to it how it will look like. This compound, once again, it is losing. This carbon is losing electron. This carbon is losing electron. The one who is being loser will develop positive charge, and this is loser, such a loser, and this is being gainer, negative positive will form a bond. So it has formed a bond like this, and positive charge. Now positive charge will rotate, it will do resonance. Once at ortho, this will come at para, then again ortho, Then in this compound, comparatively meta is more electron rich. Can you see? The meta position is comparatively more electron rich. Meta is comparatively more electron rich, and that's why, due to reverse hyperconjugation, this compound is meta director. Meta director, that means during ESR reaction, the incoming group will come and attack at meta position. So this is being meta director. 5 applications I have told you, 2 more applications have been left. So kids, do understand, I am not leaving even a single word. Are you getting? Those who know the hyperconjugation, they can really correlate that HSP Baba, your magical chemistry group, is not going to leave, you're not going to skip even a single word. Am I right or not? Just to let me know in the chat section. Am I right or not? Whatever I'm telling you. Now, application number 6. Everyone see to it. Application number 6. Okay. Now, application number 6. Oh, HOH. What is this HOH? Heat of hydrogenation. Heat of hydrogenation. Kids, this is really simplest one. But most often, most of the students, they are going to get negative marks over here. See why? Do remember first, what is heat of hydrogenation? The amount of energy released, the amount of energy released, this you will study in thermochemistry, physical chemistry. The amount of energy released when 1 mole of unsaturated compound begins saturated by bonding with hydrogen molecule or molecules. Now kids, first of all, more the number of pi bonds present in the compound, particular compound, then more will be the number of bonds will get formed. No, in this way you won't be able to understand. Let me tell you. Suppose this is one olefinic carbon, unsaturated carbon, and this is going to get bonded with hydrogen atoms. How it is going to form a bond? The 2 hydrogen atoms, one hydrogen will come from here atom and another atom will come up from here. Now, this is going to form a bond. Once it is going to form bond, its pi bond will break. One pi bond will break, and in place of one pi bond, this is going to form 2 sigma bonds. That energy will be required in breaking of one pi bond, the weak bond. Pi bond is a weaker bond. Weak bond energy is required to break this bond. But 2 new sigma bonds, too much energy has been released. too much energy will get released. Too much energy will get released. So released more, required less. So whatever the energy has been released, this is known as heat of hydrogenation. That released is more, so it is exothermic reaction. Now what I am saying, that for one pi bond is getting broken up. If we are having more pi bonds, then more number of sigma bonds will get formed and more energy will get released. So just what you are supposed to keep in your brain, that always remember that heat of hydrogenation, heat of hydrogenation, heat of hydrogenation is directly proportional to number of pi bonds. This is the point to be kept in your brain. Now, if number of pi bonds are same, then we will say heat of hydrogenation is inversely proportional to stability of alkene, stability of alkene, stability of alkene. Now kids, most of the students just remember the second point, but they forget about this point. So this point is valid only when number of pi bonds are same. Then only this point is valid. Now kids, you must be saying, where is hyperconjugation? So we can also say that heat of hydrogenation is inversely proportional to number of alpha hydrogen atoms, because stability of alkene is being directly proportional to number of alpha hydrogen atoms. So like this, and this is same, pi bonds must remain same. Kids, everyone is able to understand? Do let me know in the chat section. I think your energy is getting decreased. Everyone, do let me know. Are you okay, or your energy is getting decreased? Kids, do let me know. Are you okay, or energy? Now let me give you one question, mind-blowing question, or based on this. Let me give you mind-blowing question. So question is, arrange the following in decreasing order of heat of hydrogenation. Question is, arrange the following in decreasing order of heat of hydrogenation. Just try whatever I have told you, then only you will be able to solve this question. Otherwise, you won't be able to solve this question. Kids, try your best. So, this is your A, CH2, double bond CH, CH2, CH, double bond CH2. B is CH2, double bond CH, CH, double bond CH, CH3. C is CH2, double bond CH, CH2, CH3. Now D is CH3, CH, double bond CH, CH3. So I want to see what's your answer, whether you are able to solve this question or not. That really means a lot. Really, kids, I want to see your answer. What is your answer? What answer you are going to give, kids? Everyone, I'm waiting for your answer. A, B, C, D. Energy is low. One kid is saying energy is low. Hari Myon. Don't say like that. Kids, now Try to understand, divide it, divide and rule. Here, apply the theory, divide and rule. What I'm saying, divide and rule. This theory has to be applied during solving questions, because English people also applied this to us. Now, from where we have to divide? Divide it from here. Why? Because both of them are having 2 pi bond. 2 pi bond. Now see, these two are having 2 pi bonds, and these two are having single one, right? Now see, in this compound, this is pi bond, these two are sigma bonds, so no resonance is there. No resonance. In this compound, there is no resonance, kids. No resonance. And here, pi bond, sigma bond, pi bond, resonance. And you know that whenever there is resonance in the compound becomes more stable. This compound is being more stable. So both of them are having 2 pi bonds. When the number of pi bonds are equal, then heat of hydrogenation is inversely proportional to stability. So this is less stable, this is more stable. This is less stable, that is being more stable. So A will have maximum, A then B. It's decided. Now come to these two. Now when you see over here, this is having 1 pi bond, 1 pi bond. This is having 2 alpha hydrogen atoms, and this is having 3 and 3, 6 alpha hydrogen atoms. More alpha hydrogen atoms, more hyperconjugation, more hyperconjugation, more stability. More hyperconjugation means more stability. So this is being more stable, that is being less stable. So C and D. Answer will be A, B, C, D. Wow. I took this much of time. One kid has given answer immediately. One kid has given Muhammad Aya. You have given answer immediately. Really on the right path. Definitely you are going to get success. Your success is waiting, because you are doing really hard work. I have seen number of times in the chat section, whenever I see in the chat section, Muhammad Aya is giving really awesome answers. Number of other students are also giving the correct answer, but yes, wow, Hari Mioni car mein baithe, wow, that's really awesome. That's really awesome. So now, last application of hyperconjugation, that should be the application number 7, I think. Last application, that should be the application number of hyperconjugation, that 7th application. Now see, 7th application, heat of combustion. Heat of combustion. Now, heat of combustion means the amount of energy released when 1 mole of compound undergoes combustion in excess supply of oxygen. That is heat of combustion. Now kids, I'm not going to tell you the definition, because that you will study in thermochemistry, but see, heat of combustion, HOC, is directly proportional to number of carbon atoms. But once the number of carbon atoms are same, if number of carbon atoms are same, then heat of combustion is inversely proportional to stability of compound. Inversely proportional to stability of compound. Stability of compound. But this is valid only when number of carbon atoms same. In case number of carbon same. So this is all about hyperconjugation. I've told you each and everything in detail about the hyperconjugation, kids. Now, just to let me know, are you having that much of energy so that I can start resonance? And resonance is really the boss of all electronic effects? Do let me know in the chat section that yes, I can start with resonance. Kids, I want to see in the chat section. If you are ready, just show me the thumbs up, because and call everyone. Just try to call all of your friends. Kids, I want to see energy level, and try to call at least 10 to 20 students. And just what is this? 486 only. Let me reach the thumbs up to 500. Just increase the number, kids. Make it 500. Smash the like buttons. Hit the like buttons, kids. Okay, let's start resonance. So let's start resonance. Resonance is saying, oh, please tell all these kids about me, and let me start resonance. Actually, I wanted to have this sheet, this background. Oh, that the background has gone. The whole has gone. Oh, okay, no problem. Let's start resonance from here only. Resonance. What is the meaning of resonance, kids? Resonance meanings electron walk. Electrons move, just like you must have seen moon walk, cat walk. So resonance means simply, let me make it very simple. Resonance simply means electron walk, e walk, e walk. Now, if we want to move, we need empty space. Human beings needs empty space. We human beings are being particle, but electrons are being particle as well as wave, wavical nature, and they need electrons, as electrons are wavical. Electrons are wavical. So electron needs empty orbital, empty low energy orbital. Low energy, what is this low energy? What it means? Kids, suppose you're driving your car on the road and there is jam on the road. Now highway is there, but the height of highway is like that, like the height of metro. Now, is it possible that can you lift your car to that highway? No. If yes, this is your car moving on the road and the highway is like this and your car is in good condition, you can just jump that car and move, just reach to the highway, and you can go wherever you want to go. Just like you are provided with Scorpio car and like all these SUVs, whatever the car you are having. But if this is your road and this is the height of highway, you can't jump, you can't fly your car over there. That is high energy orbit or orbital. Orbits are having orbital. So empty orbital should be of near about, whatever the near about energy level. So this electron walk, if you want to do the electron walk, if you want that your electron should move, empty low energy orbital should be there. This is the only criteria for resonance. So I would like to say that resonance is mainly of three types. Resonance is mainly of three types. What are these three types? Let me tell you, because resonance is really very important. Once you know resonance, you can do anything. Resonance. Resonance is of three types, kids. Three types. How many types? I'm telling you, three types. One type, two type, and the third type. Three types of resonance. First type is one atom resonance. What is this one atom resonance, kids? One atom resonance. This already I've told you that negative charge is most stable on biggest atom. This is nothing other than this, that this means that negative charge is most stable on biggest atom. Now you will say that why, sir? Why it's like that? Why is like that? Because if you are having bigger atoms, see, if you are having bigger atom like chlorine, iodine, now electron will get more chance to move. Electron will move here, 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 here. Now you see, the COVID time was there, pandemic time was COVID pandemic time. Number of actor or actress, their house, or what to say, farmhouse was so big that they can do jogging, they can drive their car. There was no effect, means not that much effect of COVID on them, because their house, their farmhouse, whatever the thing, that was so big. But if you see Dharavi in Mumbai, people in one small room, 15 people were there surviving. So that was the problem. Just like this is actor or actress house and this is fluorine house. So electron is saying, oh Baba, where to move? I am not getting any space. So bigger is the size of atom, maximum delocalization is there. Maximum delocalization. Delocalization word means movement is there. So electron is saying, oh, I am so feeling good, happy over here. Now this is the first one. Now second one and third one. Second one is bag bonding. You must have heard the name bag bonding. Bag bonding. This is two atom resonance. Bag bonding is two atom resonance. Two atom resonance gets two atom resonance. So bag bonding I will let you know in detail, because without bag bonding you won't be able to do anything. And third one is mesomeric effect. Mesomeric effect. It's five types. I will let you know. These are really very important. Five types. It's five types. I will let you know. And bag bonding is of three types. These three types also I will let you know. So everyone ready? This is, I'm going to let you know the most important thing about resonance, and the each and everything is really very important. So let's start with the bag bonding, kids. Let me start with the bag bonding, because this is the most important point. Bag bonding. In short, BB, bag bonding. Now see, just to have BB, just the BB to take place, you should have doggy. Now this doggy is not that doggy who is going to bite. Now D means donor atom, atom. G means gainer atom, gainer atom. Now see kids, donor atom. Suppose I am a donor. If I am a donor, I should have something to donate. If some beggar is standing in front of me, if I don't have money, so how I can be donor? Donor should have at least some hard cash of money. So this donor should have at least one lone pair. This donor must be having at least one lone pair. And kids, this gainer, the one who is going to gain electron, must have vacant low energy orbital. Vacant, this must have vacant low energy orbital. Now, this vacant low energy orbital, which one is good? See, this should be, most probably this should be of 2p. Why 2p only? Because there is no 2D. Suppose if I'm a donor one and my family is asking me, don't donate to others, just give me. My wife is saying, just give me 2 lakh rupees, don't give to others. Then how I can be donating to others? So this 2p is the best donor because there is no 2D in the same atom, there is no vacant orbital, so it has to donate to someone else only, and this can be 2p, this can be 3D, and this can be 3p. So 3 types of back bondings are really very good. What are these 3? 2p pi, 2p pi, pi means pi electron donation, 2p pi, 3d pi, and 2p pi, 3p pi. Let me tell you kids, if I talk about 2p is donor, this is being donor. Let me tell you on next page, otherwise you will get confused. On separate page, let me tell you, it's now the donor and the gainer. Donor and gainer. Now see kids, donor if 2p and gainer is 2p, will say this is excellent back bonding. Why it is being excellent back bonding? Why I am using this word excellent back bonding? Because the energy level is same or approximately same energy level, so best. Bonding of equality is good. Now kids, you must be thinking, this question must be there in your brain, that 2p pi and 3p pi. No kids, after 2p pi, 3d pi, this is known as d orbital contraction. There is no radial node. When you study atomic structure, then you will come to know that in 3D there is no radial node, and in your JD it's given that is known as d orbital contraction. D orbital contraction. So its size becomes even smaller than 3p. So that is excellent, and this is known as good BB. And after this there is 2p pi and 3p pi back bonding. This is known as OK back bonding. So which one is excellent kids? 2p pi is being excellent, good, and OK back bonding. So these are the 3 types of back bondings. If we have an idea about these 3 types of back bonding, then definitely we are going to solve number of questions. But my dear students, most of the time, 99.9% time, students forget about back bonding. They know resonance, but they forget during examination. When solving question, they are not able to remember the back bonding. So never forget back bonding. Once again, I am telling you kids, never forget back bonding while solving questions. By solving questions, always remember back bonding. Never forget BB, otherwise BB will give you negative marks. Never forget BB. BB means back bonding, otherwise BB will give you negative marks. Now, let me tell you some examples of back bonding. Let me show you some examples of back bonding. The question is, which is more stable? Which is more stable? See, A is CF3 positive, B is CCl3 positive. Kids, do let me know what's the answer, A or B, which is more stable, A or B? Everyone do let me know. Which is being more stable, A or B? It's absolutely correct. But you have given answer B. How you have given answer B, kids? Answer is A. The same mistake done by you. You must have applied inductive fact. If you have applied inductive fact, your answer is going to be wrong. See, C is positive. Fluorine is having lone pair. Not only one lone pair, they are having 3 lone pairs, but yes, they can donate only one at a time. Now kids, it is having vacant orbital 6 electrons, only 6 electrons, and they are having 8 electrons, 8 electrons, 8 electrons. Do remember that. Don't apply inductive effect. Resonance is more dominating effect. Now kids, this lone pair will go into this 2p orbital. This is 2p and this is 2p. 2p pi back bonding. This fluorine will donate, this fluorine will donate, and this fluorine will donate. Stabilized by back bonding. Maximum is stabilized by back bonding. It's maximum stabilized by back bonding. Agreed or not? Always remember RHIS, RHIS. If you have applied inductive effect, you are going to get failed. This is more dominating resonance. Now see over here, this carbon is having only 6 electrons and this chlorine is having electron in 3p. This chlorine also 3p. This chlorine also 3p. And this chlorine is having 3d also. Its 3p is having lone pair and its 3d is vacant. Once 3d is vacant, kids, it is donating electron to this carbon as well as to its 3d also. Same chlorine is donating to this carbon, it is donating to its 3d also. Same this carbon, this chlorine is donating to this carbon as well as to its 3d also. So poor back bonding. This compound, the donor one is 3p. So poor back bonding. Are you able to understand? The one with excellent BB, the one with excellent BB and the one with poor BB, who is going to get more stability? Excellent BB is going to provide more stability rather than poor BB. Is it clear to each and everyone? Everyone, are you able to understand? Kids, do let me know. Everyone is able to understand or not? Is it clear to each and everyone or not? Now see another question. Another question. See kids, just apply your brain. Don't cram over here. Application is required. Question: which is more acidic? Which is more acidic? One is being chloroform CHCl3, one is fluoroform CHF3. Now kids, if you're not able to understand how to do it, let me help you. This will donate proton, this will also donate proton. They will get negative charge, means they will become conjugate. They will become conjugate base. This will also become conjugate base. Now, the one whose conjugate base is more stable is going to be more acidic, because acidic strength of acid is directly proportional to stability of conjugate base. This is acid, this is its conjugate base. This is also being acid, that is being conjugate base. Now kids, do let me know. So out of this X and Y, which is more stable, directly you can tell me out of X and Y which is more stable. So you are going to get the answer immediately. I would like to see in the chat section what answer you are going to give. Yes kids. And it's really hats off to you people that yes, you are still present. You see, most of the students, as the time is increasing, they have gone for sleep. But yes, really kids, salute to your hard work, and this hard work definitely is going to pay for your whatever the sincere efforts, and you are going to get the best rank kids. B is more acidic. B is being more acidic. So kids, apply your brain, apply your brain. Don't give answer like this. Just apply your brain, kids. Everyone apply your brain. I want to see your brain to get applied. Now see kids, most of the students are going to give this answer. Let me take out these two and let me explain it. See to it. So this was the question. This was the question, and let me explain. See to it. C negative Cl Cl Cl. This is one conjugate base, and this is another one. C negative F F and F. Now see kids. This carbon is having negative charge. This carbon is unstable because it is charged. Why it is unstable? Because of charge, it is being unstable. So this carbon is saying, chlorine, please take my electron. So my negative charge will get decreased. Chlorine is saying, bro, already I am having lone pair in my 3p. Where should I take your electron? This carbon is saying, bro, your 3D is vacant. Your 3D is vacant. Just take my electron in your 3D. So same, these chlorines 3D is vacant. This chlorines 3D is vacant. So it is donating its electron to this chlorine. It is donating its electron to this chlorine. So its hybridization is sp2 because this lone pair is delocalized doing resonance. So sp2 hybridized. I will explain the structure on next page. Now see over here, this fluorine is having lone pair in 2p. Now this is also having 2p. Now this is also having 2p. Now carbon is saying, see what's happening over there. You take my electron. Fluorine is saying, how should I to don't have 3D, no 2D does not exist, so I can't accept an electron. So no BB, no back bonding. This is without back bonding because fluorine is not going to donate. Carbon is having negative charge, so carbon wants to donate electron. Carbon want to donate electron. Carbon wanna donate electron. Now why you have given this answer? Because in the previous example you have seen that fluorine, here the fluorine was donor because this carbon was positively charged, but in this case carbon is being negatively charged. Carbon is being negatively charged, so carbon is not going to gain electron. Carbon wants to donate electron. In the carbocation case, carbon was having less electrons, so carbon wants to accept electron, but in carbanion case carbon is having negative charge, so carbon wants to donate electron. Can you see the difference? Thank you, Shelva Kumarji. Thank you. Only you have noticed that HSP Baba's dedication is OP. Thank you, kids. I want to see everyone with the best rank, and that's why I'm doing all these things. My hard work definitely will give you the best rank, kids. Now, see, this hybridization is sp3. Here the hybridization is sp3, there sp2. Now, what is this? Kids must be thinking, what, sir? What's happening? This much of change? Yes, kids, see to it. How much difference you want to see, you will get over here by knowledge. So, see, if you are provided with CCl3, its actual structure is going to be like this. This carbon, this chlorine, and this chlorine, and the lone pair has been donated, so its structure is delta negative, delta negative, delta negative, delta negative, and it has developed, single bond has developed partial double bond character, so it is trigonal planar sp2 hybridized and trigonal planar. You can see the structure also, trigonal planar, and this is all happened because carbons 2p lone pair has been donated to carbons 2p has been donated to 3d. So this is the type of back bonding. But if I talk about CF3 negative, so you can see this is the lone pair, and fluorine is not going to accept its electron, so its structure is like this, and carbon with negative charge, you can see pyramidal shape sp3 hybridized. The shape is like ammonia, pyramidal shape. So kids, I hope you got it. So who is being more acidic? Your answer is this is being chloroform is more acidic. Chloroform is the correct answer. I hope everyone is able to understand. Everyone is able to understand. Do let me know, kids. Hey kids, do let me know in the chat section that yes, everyone got it. Thank you, Shiva, Shivtha. Thank you, thank you, thank you, thank you. Now, well-known example of back bonding is inorganic benzene. Inorganic benzene. Have you heard this name? Have you ever heard this name? Inorganic benzene. Also known as borazole, or triborine triamine. So what's that? That is B3N3H6, B3N3H6. Now let me draw it. B3N3H6. B N B N B N H H H H H H. Now you see, atomic number of boron is 5. Atomic number of boron is 5. So 2 and 3, only 3 electrons of boron and 3 electrons of sharing. Boron is having total 6 electrons. 6 electrons. So this boron is having 6 electrons only. So it is being electron deficient. So kids, if it is electron deficient, this is also electron deficient. All 3 borons are being electron deficient, and all nitrogens, they are having lone pair. The nitrogen's lone pair is in 2p orbital, and boron's 2p is vacant. What thing is coming to a brain? Is there anything which is coming to a brain? Could you please let me know? If you want to solve the questions, you should have to have at least some information, whatever I'm telling you, whatever I'm teaching you, whatever I taught to you kids, whatever I have taught you, you should have to have at least some knowledge, then only you can solve question. So kids, back bonding will take place, and once the back bonding is taking place, how it will look like, let me draw that structure on another page. This compound will look like this. See to it, it will look like this. Boron, nitrogen, boron, nitrogen, boron, nitrogen, all they are fitted with hydrogen, 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 and nitrogen has donated electron. Nitrogen has donated electron, so positive charge, and it has gained electron, and due to this they have formed extra bond. They have formed one extra bond. Can you see? Same here, positive, negative, and extra bond. Same here, positive, negative, one extra bond, and it's looking like benzene, and that's why it is known as inorganic benzene. I think this point is very much clear to all of you why this is known as inorganic benzene. The reason is in front of you, you can see very clearly, because these pi electrons are back bonding 2p pi, back bonding 2p pi, 2p pi, 2p pi, pi electrons back bonding 2p pi, BB, excellent BB, and due to this it is known as inorganic benzene. Kids, I hope this much is clear to all of you. Everyone is able to understand. Do let me know in the chat section that yes sir, I'm able to understand, I got it, I got it, I got it. Now I'm going to tell you mesomeric effect, 5 types of mesomeric effect. But kids, do let me know how is the Josh. Hey kids, I want to see your Josh. How is the Josh, kids? Do let me know, everyone. So your like buttons have been reached to 501. That's thanks to each and everyone. And now we are going to start with mesomeric effect. Tell everyone, all the friends, all, let them know, each and everyone, sir is teaching you mesomeric effect. Sir is going to let you know about mesomeric effect. Thank you, thank you, thanks for your so many likes given by you kids. Now mesomeric effect, we are heading towards mesomeric effect. Mesomeric, welcome, welcome, welcome. Mesomeric effect. Now kids, one more question must be coming to your brain. What's the difference between mesomeric effect and resonance? Number of times this question must be coming to your brain. What is the basic difference between mesomeric effect and resonance? So kids, see to it. If I say this mesomeric effect is like uh, Punjabis, and this resonance is like Indian. Could you please help me? So I would like to say, all Punjabis are being always Indians, always. But all Indians need not to be Punjabi. Not always. Not always. That means this is big set, this is small set. Mesomeric effect is always resonance, but resonance is not always mesomeric effect. Are you getting it? Are you able to get it? Everyone, are you able to understand that these are being Punjabis, these are being Indian, and All Punjabis are always being Indian, but all Indians not always need not to be Punjabis. Kids, everyone is able to understand. No, no, not all, not complete syllabus, kids. Resonance is very lengthy. Resonance, I won't be able to cover it. I have started resonance. Resonance, some points I will let you know, but applications I will let you know in another session because it's very lengthy. Kids, resonance is very lengthy. We won't be able to cover complete resonance. Okay, kids? Now, this is the main difference, and five types of mesomeric effects are known, kids. There are total five types of mesomeric effects. Let me tell you, kids. Mesomeric effect is also known as resonance. It is also known as delocalization. It is also known as conjugation. It is also known as conjugation. Kids, these are the names for mesomeric effect. Mesomeric effect, resonance, delocalization, conjugation. Now, mesomeric effect is mainly of five types. Mesomeric effect is mainly of five types. Are you ready? Yeah, definitely I will questions. I will ask questions. Definitely I will ask questions, right? See, five types of mesomeric effects. So, C double bond C, and if this C is having double bond, this is pi conjugation. First one. Second one is C double bond C. If any atom, let me give you detailed one. Let me give you a detailed one. See to it, kids. If this is any atom Z and it is attached with double bond, pi conjugation. Second one, C double bond C and Z is having negative charge. Third one, C double bond C if Z is having lone pair. Fourth one, C double bond C if Z is having positive charge. Fifth one, C double bond C if Z is having free radical. These are the five types. Out of these five types, this is the best. This is known as pi bond conjugation. Energy level is near about same or approximately same. That's why this is the best conjugation. Best conjugation out of all these five, best conjugation. This is best conjugation. This is pi bond negative charge. This is known as pi bond negative charge conjugation. This is known as pi bond lone pair conjugation. This is known as pi bond positive charge conjugation. This is known as pi bond free radical conjugation. Now, kids, these are the five. I will ask questions. Right now, I am not going to tell you the details. Details I will let you know after the questions, after asking questions. Now, on this basis, let me ask some questions. Let me ask some questions just to find out whether you are able to keep it in your brain or not. Question is, which compound is not showing resonance? So see kids, A, B, C, D, so what's the answer? I want to see answer kids. Everyone do let me know what's the answer. Yes kids, D. See, more than one may be correct. More than one may be correct. D. Yes. D is the correct answer. You kids are really intelligent. Thanks for that. D. See, this is having back bonding resonance. Back bonding. 2p pi, 2p pi back bonding. Two atom resonance. Two atom resonance. So, see kids, this two atom resonance. This is having pi bond conjugation. This is having lone pair pi bond conjugation. That's really fantastic. First answer is fantastic answer given by you kids. Now see to it. Question number 2. Question is, which is not having mesomeric effect? A is B is C is D is. What's your answer kids? What's your answer? Everyone do let me know what's your answer kids. I want to see your answer. D. Once again, D is the correct answer. D is the correct answer. There is no mesomeric effect. Here is lone pair pi bond conjugation, is lone pair pi bond, and here is pi bond conjugation. Now kids, I'm going to let you know the most important thing. Just try to understand. I'm going to tell you most important thing. Everyone try to understand. Most important points. Point number one is really very important, really most important point. If any atom is having pi bond in conjugation along with any of these negative charge or lone pair or positive charge or free radical. Kids, what I have told you, which one is the best conjugation? Which one? Just like if you are having one gun, one stick, one scale, and some enemy is coming, and you are soldier, then what you are going to use? The gun, the stick, or the scale? Definitely the best thing you are going to use, that you are going to use gun. That is the best. So out of 1, 2, 3, 4 or 5, you are provided with the gun along with the stick or whatever the thing, you are going to use the best one. So what is the best one? The best one is pi conjugation. So pi conjugation is best. So definitely you are going to use the best one. So if any atom is having pi bond, then pi bond conjugation will take place. Rest of others will remain localized. Localized means will not take part in resonance. Okay, so this point is really the awesome point. If you don't know this point, you won't be able to solve most of the questions. This is really very important point. Now let me give you questions based on this. See to it, everyone. Suppose if I'm going to draw compound like this, I'm going to draw compound like this. This is known as pyridine. You know very well pyridine, compound pyridine, bad smelling compound, pyridine. Very well known compound, famous compound, pyridine. Now see kids, this nitrogen is having this pi bond as well as this lone pair. Now out of these two, only one can do resonance with other pi bond. Then who is the best one? The pi bond is going to do resonance or the lone pair will do resonance? Just to let me know kids, out of these two, who is going to do resonance? So the answer is pi bond conjugation is the best conjugation. So these two will do resonance and this will remain, this lone pair will remain localized, means will not take part in resonance. So it will remain out of the plane. These are taking part in resonance. This lone pair is out of the plane. So when you are going to count steric number, you will count this sigma bond and one lone pair. So two sigma bonds plus one lone pair, they are being localized. So the steric number is going to come out 3. So the hybridization is sp2. So this is about pyridine. Now kids, if I want to talk about pyrrole, see, if I draw a structure of pyrrole, this is your pyrrole. Let me draw the structure of pyrrole. This is your pyrrole, kids. This is the structure of pyrrole. And you just see to it. This pyrrole, this is having just lone pair. It is having lone pair, no pi bond. So its lone pair is delocalized. This is being delocalized. And what I've told you about pyridine, its lone pair was localized, means not taking part in resonance, because this was having both. So kids, do let me know who is being more basic out of pyridine and pyrrole. Which one is more basic? The question is, which one is more basic? Which one is more basic? Kids, do let me know. This is pyridine A, that is in pyrrole B. Out of A and B, which is being more basic? Do let me know, everyone. Everyone, do let me know, kids. I want to see in the chat section what's your answer, kids. So A is being more basic because it can't move. It can't move. So it is localized. Localized means can't move, and it's delocalized means involved in resonance. Means involved in resonance. It's moving. It's moving. That is involved in resonance. So easily, proton can easily, you know it, the mosquito, one mosquito is just seated over the wall and another mosquito is moving inside the room. The one who is seated, means localized, can be easily trapped. So can easily, this proton can very easily attack, can be attacked very easily. So this is being more basic. More basic. Now kids, see to it. Another thing which I am going to tell you about the second point. The second point, once again, it is also very, very important. You can see the extension of the first point only. So I'm better to say, I'm going to give you a question. Question. Which lone pair or which lone pair is delocalized? Which lone pair is delocalized? See to it. A, B, C, D. Yes, kids. Do let me know in the chat section what's your answer. Which lone pair is delocalized? Yes, kids. Do let me know. B. B. Yes. Who has given this answer? Muhammad Yahya. Atif. Very good, everyone, kids. Really awesome that this lone pair is delocalized. This is localized. This is being localized. This is also being localized. Now, one more really good question, because I am so happy because you have given best answer. Question is, which charge which charge is delocalized? Which charge is delocalized? Which charge is delocalized? See to it, kids. A is like this, positive charge. B is like this, negative charge. C is like this, positive charge. D is like this. So what's your answer, kids? Do let me know. What's your answer? I want to see your answer, kids. Yes, kids. I'm waiting for your answer. Hey, kids, I want to see your answer. D. 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 Yes, absolutely correct. D is the correct answer, because here is lone pair and this 2p. This is 2p and this is vacant 2p. 2p pi 2p pi. Excellent back bonding. 2p pi 2p pi. Excellent back bonding. This is really awesome, kids. Fantastic. So your answer is absolutely correct. Your answer is absolutely correct. Now, kids, the last topic for today, which I am going to tell you how to compare the stability among resonating structure, that which resonating structure is being more stable, which resonating structure is less stable. Right, kids? Everyone, this is the last topic for today. I know that you are having too much energy, but yes, tomorrow morning you have to wake up early in the morning. So for that, you have to sleep. Okay, kids? So this is the most confusing for most of the students. They find it most difficult, and most often they are going to commit mistake over there. So this is the most important point, that how to find out which resonating structure is being more stable, which is being less stable. Okay, so ready? So let's compare stability of resonating structures. Stability of resonating comparison for stability of resonating structures. Whatever the points I am going to tell you, you have to know the sequence. Kids, you just do let me know. If you are having a healthy person, that healthy person without any disease is more stable, or the person suffering with some disease, whether it is due to less eating or due to more eating, less vitamins or more excess of sugar, definitely your answer is going to be the one who is healthy, is without any disease. So kids, over here also, the first point, my lord, the first point to be noted is the compound without charge is more stable. Entity, this is the first point, do remember, entity, entity without charge is more stable than the charged one. Now see kids, how to find out this structure's validity, this point's validity, what we have written, how to see it. See kids, if I'm going to write compound like CH3, C double bond O CH3, this is in the neutral form, and if I write like this CH3, C positive O negative CH3, so definitely this is going to be more stable, that because this is being without any charge. So this is going to be the stability order, and we know very well, no doubt is over there. This is the stability order. This is going to be stability. I hope this point is very much clear to all of you. Now in support of this point, first point, let me give you one more structure. In support to this, let me show you one or two more structures. See, if I draw phenol, we know that very well that phenol will do resonance. So its resonating structures, number of resonating structures will be there. 4 more resonating structures will be there, like this, double bond, positive and negative charge. So from your childhood, you must have seen phenol like this, the first one or the second one. Definitely in class 10th or 11th, you must have seen the phenol's structure, this one, because this is without charge. So the stability is moving in this direction. This is more stable, and that is being less stable. So stability order is like this, because this is being without charge, this is being without charge, and the one without charge is always going to be more stable. This is a charge entity, and charge entity is going to be less stable. So the first point is very much clear to all of you. Everyone, are you able to understand this first point? Now see, try to understand the second point. This point is really very important, and mostly the students, they do most often they do make mistake over here only. Second point, both are charged, if both entities or resonating structures, both resonating structures are charged, then what to see, how to find out the answer? This is the really most difficult question, and mostly you are going to make mistake over here. See kids, this is really, I'm going to make it very simple. Just follow my point. You can see the entity or the resonating structure with complete octet of all the atoms, now you will say, sir, hydrogen's duplet complete. So the resonating structure with complete octet of all the atoms is more stable, or will be more stable than without complete octet. Now kids, this is really important point, and this point can also be written by other means. The same point can be seen with different angles. See what I'm going to write. The same point can be seen with different angles. See to it. Let me write down. Or the entity with more number of covalent bonds will be more stable. Both mean same. Now you will saying that you must be thinking like that, how the meaning of both 2 points is same. Let me give you example. If you think about this compound, just see to it. If I write down this compound CH3 CO positive, one is this compound and another compound is like this CH3 CO positive, and if I ask you this is X and that is Y, which is being more stable, then mostly you are not able to give the correct answer. Most of the students will get failed in this. Out of these two, which is being more stable? I want to see answer. Out of these two, which is being more stable? Kids, do let me know X or Y, which is being more stable. I want to see your answer. Gokul is writing Y. Now I want to see others answer, kids. What other students are going to give the answer? I want to see everyone's answer, kids. So everyone is writing yes by B. So kids, definitely the correct answer is Y. Now let me take fresh page to explain it. Otherwise, most of the students must be thinking that positive charge is least stable on more electronegative atom. So this is by chance. This plus charge will be at oxygen. This plus charge will be at oxygen, and most of the student must be thinking like positive charge is less stable on more electronegative atom. But don't apply this point on second number. On second number, we have to apply these points only. Now let me explain it. This was the compound given as CH3 C double bond O positive. Now you can see very clearly this carbon was having only 6 electrons. This oxygen was having 8 electrons in the valence shell. Now kids, this carbon's 2p orbital is vacant. And this oxygen is having lone pair in 2p. Now this will act as donor. This oxygen, one lone pair, will be shared in between these two atoms. Now how it will look like? See, this oxygen will donate 1 electron. It will remain 7 only over here, and it will develop positive charge because this is the neutral one. This atom is being the neutral one. So it will develop positive charge, and this is positive charge. This will become neutral. So how it will look like? It will look like this CH3 C double bond O, 2 electrons and 1 electron, and 1 electron is gained by this carbon. So its positive charge will go away because this positive charge has accepted 1 electron. So this will become neutral, and that will develop positive charge. Now it is having 7 electron, it is having 7 electron. Both of them are having 7 electrons, so they will make another bond by sharing. Sharing is caring. They made another bond, new bond. Now see, both of them right now are having 8 electron. This is having 8 electron, and this is having 8 electron. Now question must be arising in your brain, sir, earlier also it was having 8 electron, now it is also having 8 electron. Now how is it possible? Although it has donated 1 electron to carbon, now how is it possible that it is having 8 electrons? So kids, the one electron it has donated, it is sharing. Now by sharing, it is having one electron. Just like kids, if I'm having 1 lakh rupee, another partner is having 1 lakh rupee, and we have shared 1 lakh, 1 lakh. Now we are having 2 lakh rupees. Now, if I kick that friend to be called as the false friend, if I kick him out, now also I am having 2 lakh rupee. Earlier 2 lakh rupees were in sharing. Now those 2 lakh rupees are belonging to me only. That is either belonging to you only or it is in sharing. Right now, these 4 electrons were the property of this oxygen only. But now once the sharing, 2 electrons are in sharing and 2 electrons are remaining like lone pair. So it is called sharing. Now, kids, which molecule is more stable? This compound is having one atom with only 6 electrons, and there all the atoms are with 8 electrons. This is with 8 electrons, that is with being 8 electrons. So this compound is being more stable. Why it is being more stable? Because everyone's octet is complete. Now you can see this is having 2 covalent bond, this is being extra covalent bond. Extra covalent bond, and you know that whenever bond is formed, whenever bond is formed, energy is going to get released, because energy is required to break the bond. But once the bond is formed, energy gets released and compound becomes more stable. So exothermic reaction, because it is having more bond means less energetic. Less energetic means more stable. Now kids, the third point and the fourth point. After that, yes, we will make a full stop. But before that, let's see the third point. What's the third point? Third point is, so you know very well, it's your favorite, that negative charge is more stable on more electronegative atom, and positive charge is more stable on less electronegative atom. Now see kids, let me explain this point clearly. Suppose if I am provided with X structure, that is HC double bond O, OH formic acid, Y HC positive O negative OH, and Z HC negative O positive OH. Could you please help me in determining the stability of these three structures? It's definitely this is going to be the most stable, no problem, because this is without charge. X is going to be most stable. Now out of Y and Z, you can see this carbon is having 6 electrons, and here this oxygen is having 6 electrons. Now octet is not complete, because the octet is not complete in both of the two entities. That means second point has become null and void. Now we have to come to the third point. Now here positive charge is on carbon and their negative charge is on carbon. So definitely X, Y and Z. This is going to be the stability order, and this is going to be the answer. Kids, are you able to understand? Everyone is able to understand. And the last point, last but not the least, see to it. This to you know very well. The fourth point. This to everyone knows. Fourth point. See kids, that opposite charges must lie nearest to each other and same charges must lie far away. Now see kids, if I draw resonating structure, one like this, it's phenol once again, one like this, one like this. Now see kids, this is your last question for today. This is being X, this is being Y, and this is being Z. Now one to you know very well that X is going to be more stable. Now after Y and Z which is being more stable. Out of Y and Z, what do you think which is being more stable? Kids, do let me know. This is the last question for today. After this, the class will get over. 1, 2, 3. Kids, do let me know properly what's your answer. After 1 is definitely more stable. Out of X, this X is more stable. Out of Y and Z. Kids, out of Y and Z, what do you think which is being more stable? ZY, very good. See, positive charge and negative charge. This is not delta. It's simply complete positive. Now, distance is too much. Between positive and negative distance is too much. And this positive and here is negative. Sorry kids, it's negative, not positive. It's negative. Negative. So structure was written wrong by misprinting, by slip of the stylus by chance, right? Otherwise, I think that's why you're not able to give the answer, correct answer, right? So definitely X, Z and Y. X, Z and Y. Now I'm going to give you question for homework. Should I give you question for homework, kids? This you have to search, you have to find out, you have to try by yourself. Question for homework. Question is, which compound will not show resonance? Once the video is over, just try to find it out and better to write down in the comment section, okay? So, out of these 4 options, answer is there. One answer is there. And kids, really it was the marathon. I hope that everyone must have enjoyed it. You liked it. Kids, how was the theory part? How was the questions framing? How was the explanation? I think everyone must have enjoyed it. And once again, I would like to say thanks for being with us, because your presence is the most precious presence. Your presence is the most precious present which I could have. So, for the best selection, always say to yourself that you are important. Self belief, that is the most important thing. And kids, do proper revision. Just you wake up in the morning. When you wake up in the morning, do the revision without opening the notes. Whatever you have studied today, try to revise it tomorrow morning. By tomorrow morning, definitely when you wake up in the morning, there is, you can say, sun rays are coming. At that time, UV rays are coming, and those rays will definitely try to form the photographic memory, and they are going to help you kids. So bye to all of you kids. Definitely will meet you in next session of resonance, that the second part of resonance, very soon. In that, I will let you know the applications of resonance. And really, today we have done a lot of part of the GOC. The most important part, hyperconjugation, we have completed. Inductive effect thoroughly we have completed, and resonance part also, a small part of resonance we have completed. And definitely resonance and its application I would like to tell you in the next session. So stay tuned. Bye to all of you. Good night. God bless you kids. God bless you.